Thanks, everyone, for joining us today. We have a lot of good info we want to share with you. I'm David Stanford. I'm a director in our customer experience chief technology office, and this is my colleague, Faisal. And we're going to go through some different things around Cisco data and Splunk and how we can maximize AI capabilities today. So for this session, if you go to the next slide here, you can see that there's a lot of different things you can do as far as best practices. And we want to talk through that today. And one thing to keep in mind is data is the currency, right? Data is the most important thing you can do here. So real quickly, I'll show you the agenda. We're going to do a quick introduction, what the session is, why are we doing AI in networking, and some of the use cases we're going to look at there. The role of data from Cisco and Splunk, and also third party. And then we'll talk a little bit about some 3 core use cases, some best practices, some challenges and solutions we've seen, and a customer success story that we worked through recently. And with that, Faisal, if you want to do the introduction to the session.
So, Faisal Azizullah, and I'm joined with David Stanford today. What we're going to be talking about is a methodological way of how you take Cisco telemetry data and how you input into Splunk, and then how you get actionable insights from it. So throughout the session, you'll see us going through these building blocks of where we're getting the data, how we are inputting it into Splunk, how AI is working within Splunk to give you that actionable insights.
So why AI and networking? I started at Cisco about 25 years ago. Even back then, networks were complex, but nothing like it is today. Billions of endpoints, billions of devices and users. We have hybrid architectures, multi-tiered applications. Everything is real time. And to do that, we need to capture a lot more information. We need to have things that are sent real-time telemetry. We need to do correlation, deduplication. But we really want to have real-time insights. Real-time is key. And so with that, it provides us a lot of opportunities. Some of the things we're going to talk about today include predictive maintenance. How can I predict faults with our hardware or software and actually prevent that from causing an outage? How do we do real-time network optimization? And of course, security. Security is everywhere. It's embedded in everything we do, and especially in AI. Now, the role of data. The first piece of this is the Cisco data. So I've called out a few things here, like Catalyst Center, Thousand Eyes, Meraki, XDR, but you know there's much more than that, right? There's all the infrastructure devices. These are some of the domain controllers, some of the different solutions, but we also have third party. We have other things like Intersight. We want to make sure that we're trying to break down silos. And I think that's the biggest thing. Every time you purchase something, whether it's through Cisco or another vendor, you have another domain you need to manage. And you know, everybody talks about it, I've been talking about it for 20 years, the single pane of glass, but how do we ever get to that? I think the key here is to take that telemetry that comes from these devices and controllers and get that into something like Splunk. And that way we can actually already have granular network visibility. Something like Catalyst Center understands some of the different faults that are there, understands some of the different automation, and we can get this into Splunk to take more actions. And we can actually bring all of these different silos together. And so we're talking about proactive from reactive. We've very much been reactive in the past. And I think there's been a lot of fear, a lot of hesitancy for automation to take on a lot of these different areas. Nobody wants to say, hey, just automatically go change my network. But with AI and what we're doing with Splunk, we can start to do that. So automation and AI are a very important part of this.
So David talked about Cisco data. That is our source where we're getting all the data. Now comes the Splunk part of the things, right? So Cisco is providing us rich network telemetry, right? Powerful platform insights and everything. What Splunk does is it ingests all that data in it, right? And then once it have ingested that data, it starts processing that data, correlating that data. Because the thing that David touched upon is the data silo thing, right? You're getting data from your firewalls, your routers, your switches, application data. Now, how do we correlate all of that data? Splunk is providing that piece to us. Again, going back to the single pane of glass. So everything is now correlated with each other. That's where Splunk comes into picture. Splunk does more than that. It is correlating the data. It has AI models in it. You can even write machine learning things in it. So not everything can be solved with AI. You have some machine learning, which you are detecting patterns. You're looking at things, anomalies, anything that deviates from your happy path. You want to detect that, and then you want to see, hey, is this something that is in there or not? So that's what Splunk is helping you with. Next, I'll go into the telemetry workflow. We're getting the telemetry, right? We're getting it from you collecting data, routers, switches, and everything. What happens after that? After that, I put everything towards Splunk. I have my application data going through Splunk, syslogs going to Splunk, router data, switch data, anything and everything that's part of my ecosystem is going into Splunk. Now comes the cleaning process. Think of it as like you got crude oil, now you want to make petrol and diesel out of it, right? So you clean it up, and then you get the finished product. That's what Splunk is doing. It's taking that data out. Is anything missing in it? It's discarding it. And whatever is useful and can be of value, Splunk keeps that. Then comes the AI part of it, the analysis and anomaly detection. So we are on the third step over here. What it is looking at is now inferencing all of data. It's looking at, okay, I got this data, this is a path, the database, let's say an application is calling a database, right? So from the application server, we get a route that is going to a different data center where database is hosted. Okay, this looks all good. But now I'm seeing these two other paths that are going somewhere else. They should not be there, right? Or maybe you're getting data from a circuit, SD-WAN circuit, which is being heavy and it's flipping. So all of that is now AI is working on it, and this is built into Splunk, and it is looking at it. Then comes the third step where we are doing the predictive insights. So now we have the insight, the historical data, everything. Now the model starts churning, and it's looking at, okay, well, this is happening. In the past, I've seen if this is the load on a network bridge goes above 400 megs or 500 megs, I'm just giving an example, the bridge flips, right? So my SMB or something might flip. So what do I need to do? Well, maybe I can create a ticket in ServiceNow and go from there. Or maybe I can deviate the path. I can give another path to it. So it goes back. And so Splunk has that capability. And we'll go in detail over there. It goes back and reconfigures your network. That, hey, you get this packet. Now this packet has to, instead of going this path, it has to go through that path. Then comes our actionable response and optimization. This is the path where it is taking an action. And it all depends on you. You configure, yes, you can take that action, or you want to stop there and be like, oh, a human would come in and take that action. But the thing that we are seeing with most of my customers is they want to remove the human from the middle because that takes time. And in today's world, if you have a security threat or any other thing, you cannot wait. But again, it depends from your business to business, what do you want to do? And then the very end, what the agentic framework that we are going to talk about is, you can write your own agents in Splunk too, by the way. But Splunk gives you a library of agentic frameworks, agents that can do work for you. Maybe you want to open up a ticket, or maybe you want to shut down a port. That agent would go and do it for you. So that comes the place where we are trying to get the human out of the middle, and the agent is working for you. And again, the thing is, this all can be configured by you, and it all has a feedback loop to it. So coming back to this thing, we got at the bottom, we are taking all the logs, metrics, traces, everything from Cisco. We got into Splunk observability. I want to spend some time over here on the AI-powered analytics and predictions. There are 4 major models within Splunk. You have the anomaly detection, predictive maintenance. So what does anomaly detection does? Anomaly detection is like just looking at anything that is deviating from your normal path or happy path, right? It goes there. Predictive maintenance, we have 2 models in there, LTSM and ARIMA. Both of them are looking at, okay, if this has happened in the past, how do I not do it in the future? How can I prevent it from doing it in the future? Then comes your root cause analysis, where we are using Bayesian networks and decision trees to do the root cause on it. And all of this is these models that are running in there. The threat detection is the last model. But all of these models that are running there and there, they're getting a feedback loop back into it. So whatever decision they made, it comes back to them. Why? Because there's a thing called, we're going to talk about it later too, model drift. So we don't want to make the model to drift from what we trained it on. And then comes your last layer, which was our agentic thing. We have two things, which is self-healing networks, and then the Splunk SOAR. Self-healing network is self-explanatory. It will go and fix your network and do things. The Splunk SOAR is the part where it would go and reconfigure your network. So you're giving it the ability that, hey, this is my device. You can log into it, and then you can change the configurations on it. And let's say if something bad happens, it would recall back and then go back to the previous thing. But the thing is, these agents have been tested, and they have worked. Well, I don't know. We have seen one single instance where it has not performed well. But knock on wood, we cannot say that it won't do it in the future. But the ability is there. You can fine-tune it, be like, okay, this is much I'm comfortable with. This is not what I'm comfortable with. So you can do that. And that's what this helps you with. Next, we'll go to use cases and best practice.
Yeah, so we're going to talk about a couple of use cases that we've done both in Cisco and with customers. So these are real examples, but I have a quick poll for the audience. How many of you here have multiple Cisco domain controllers, like Intersight, DNA, a Catalyst Center, multiple, a mixture? How many are in a multi-vendor environment? Yeah, so no surprises there. So this is very important when we talk about pulling all this information to understand what's happening. So if we go to this here, the first use case is predictive maintenance. And really what we want to do here is leverage the health data or the information we get from controllers like Intersight. In Intersight, we're looking at compute platforms. We're looking at UCS. And things we check are like the memory statistics, or the memory information, the DIMMs, the storage. And we're trying to make it so that we don't wait for a failure. We look at all this information, we bring it in, we continue to track, and we look at predictive analytics where we can determine if something may potentially fail. So this is one of the things we've done with Intersight and Splunk. And in that instance, we have something called proactive RMA, where we can actually predict that something's going to fail, get the hardware out to you beforehand. Or with software, we can look at, hey, you're about to hit some bug because of this configuration change, and we can actually automate and remediate that. So really, it's about reducing downtime. It used to be we were very reactive, right? We get a trap, or we get the failure, and then we have to wait 24 hours, 48 hours before we can even process it. Now we're getting the hardware out to people before we even have those failures to prevent it. Use case 2, network optimization. And I think this is really important because networks now are more complex than ever, like I mentioned before. And we really want to do things where we can improve traffic, reduce congestion, move workloads from one data center to another. And this is all done constantly collecting information from the different sources. Not just the Cisco controllers, but we also have things in CX like our CSPC controller, our net profiler, which gives data about all the different devices. And really we want to do, and it looks at the configurations as well, so we can actually help to make the proper changes if we see something that's out of the ordinary. And so anything from data centers, branches, WAN links, even like I mentioned, applications. One of the common examples that we've run through recently is power consumption or power costs. Is it cheaper to have an application in a data center in St. Louis or North Carolina? We can do analysis time of day based on the modeling and determine, let's migrate that application over to another data center because the cost goes down at night. So there's a lot of analysis. The data is the most important part. And the more you want to collect and continue to collect, you prevent that drifting, that model drifting.
Security incident detection. That's our third use case. Talking about is, cybersecurity threats, they're evolving and they are unpredictable. We cannot predict what is happening. We need to be detecting malware attacks. We need to know insider threats. And we also need to know zero-day vulnerabilities that are happening over there, right? So Splunk has what you're looking over here is the Splunk anomaly detection. What it does is this dashboard gives you is it collects data. Splunk has its own database which is looking all across the world what is happening, and it is giving you that insights. At the same time, it is also looking in your network and seeing if it's figuring out or it detects something that is happening in your thing. It takes data from other Cisco products too, XDR and stuff, where it is looking at like when let's say, for example, you get a malware in your environment, right? It would even give you a history where the malware started and where it started actually proactively working in your environment. So maybe it started like 3 days ago, but it was very dormant, but now it is making all that noise in your network. It will give you all that insights in there. And Splunk does that, is able to do that because it's getting all these telemetry points from different devices in your network. So you're from your end devices, like the user device, which is getting the traces and metrics from there, the routers and switches, and the firewall that comes all in the path. It's taking that and correlating and putting that all for you. So as a security engineer, you can tell it, hey, mitigate that risk, or maybe your company has a different policy. You have a threat detection team that will take and mitigate that. So either way, Splunk helps you doing that. I want to do a technical recap that what we have talked so far. We've talked about data flow. That's the most important thing. Your data has to be clean. Your data has to be primed to be input. And Splunk, if you see this picture, Splunk is the center of this picture. We're getting data from IoT devices, all Cisco controllers, everything. Once the data gets ingested, it goes through those AI models. What they do is they clean the data, missing information is got out, and it is now pristine for the model to get trained on. The model trains on this data, gives you actionable insights, and then it starts its work. It starts giving you prediction, anomaly detections, predictive maintenance, security threat intelligence, everything that you can do, it will do that for you in real time. And there's a feedback loop. The model is constantly retraining in that. So this is what we have talked about the technical architecture. Some of the things that we wanted to take into control. First thing is data quality. I cannot emphasize enough. Data has to be there. And we look at it, we take our data into low, categorize it into low, medium, and high. Low being that it's relevant, but the data might not be the cleanest. And high being the best data. It takes all of that data, it churns that data, cleans that data out for you, and then it has an AI refined data. Now comes our feature engineering. Why do we need that AI refined data? It takes all those data points, and now it is going to create features from that data, meaning that when I do this correlation, I know, hey, I'm looking at, for example, a user's latency is happening in a website or an app that he's using. I can correlate that data by making a new feature, which is talking about, hey, my latency for this feature in the app, let's say an ad is popping up in the app and that is being latent. So we can do that level of granularity, and then we can see, okay, for this ad, because the data is coming from here, that's why we're getting this latency. Splunk is providing you with that because it is doing that feature engineering with this. And then last comes the model evaluation. That is where the model drifting that I'm been talking about is. We constantly evaluate our models against real-time scenarios. So like anomaly detection model that is available in Splunk, it is being tested every day, multiple times against different anomalies, just to make sure that the model is working right. And let's say you bring in your own model, and we recommend you to do the same thing because, anomalies there are new anomalies that are coming every day, right? Just like your cybersecurity threats. We don't know them, a new threat comes in, and then we react to it. The whole idea of doing this is we want to be proactive than reactive. And that's what Splunk is providing us, and that's the power of Splunk that we have over here.
Oops, so the animation didn't work there, but some of the best practices for the implementation. Obviously, when you're looking at a use case, start small. Don't try to boil the ocean, right? If you're looking at predictive analytics, looking at RMAs, start with that certain hardware feature. If you're looking at energy, look at what you're doing on a subset of devices before you start to scale out and look at performance management, utilization across the network. Automate data pipelines. Use the APIs. APIs are everything. I mean, we're API first. That's the big thing for us. So there's different connectors built in. And as Faisal has mentioned before, continue to monitor and improve your models. The more you update, the less drift you're going to see as well.
So obviously, with everything, there are challenges. There are 3 challenges I'm going to talk about today: data silos, model drift, security, and privacy. Data silos is a big thing, and being in the network industry, we all have that problem. We have feeds coming in from different sources. Like David was mentioning, there's no single pane of glass. And I have been there in that NOC for years in my life. I have spent that time over there. And we have like screens after screens. And we're looking at, okay, this happened over here, stop it here. Now let me look over in this log. Is it happening over here? What is happening? What is my next hop doing? Where is the thing? That's the thing that Splunk came in, and it correlates all that data. So yes, there's still data silos. We need to put all of this in. And in the previous slide, as David was mentioning, APIs. We have APIs for everything. You can even import a syslog into Splunk. So that makes it very, very easy. You don't have to have an HTTP endpoint or anything to move your data into Splunk. It is doing that. Model drifting, Splunk, the models provided by Splunk, they are trained every day. Another thing, if you want your own model, because there's lots of models out there in the market, Hugging Face is your friend. But at the same time, you want to use your own model, your company made your own model, you can train your model and make sure you keep training that model on a daily basis or maybe on a weekly basis, just to make sure that it is up to date. Because as your network is evolving, your model needs to evolve with it. And then the third part is the security and privacy. What we're taking thing is, you don't want to give access to everybody. Implement role-based access on everything. And we have been doing that within our routers, our switches. Everything that Cisco provides has this capability. But the thing is, there are things beyond our Cisco ecosystem that are part of the whole ecosystem now. And new things are coming every day. So make sure there's a secure part to everything. You put RBAC in there, and then you go from there.
I want to talk a little bit about a customer we work with on something where we brought this together. This was a service provider in the US, and they came to us about a year ago and said, by January 2025, I need to reduce the power in my buildings in New York by 75%, or I'm going to get $1 million fine. And that fine's going to be exponential until I prove I'm doing something. So we said, okay, let's do this. Let's go in and look at one of the data centers in one of the buildings, and let's just do a power assessment. Like, what's your power consumption? What's your utilization? And very important, we wanted to make sure it was real power statistics, not the data sheets, the average utilization. So we went in, we had multiple sources. We had Intersight for UCS. We had the CXCSPC collector. We had DNA Center or Catalyst Center. Yeah. But we had the same challenge. How do we pull all of this together? How do we get all the energy utilization? They even had Grafana and Prometheus that was collecting data. So we streamed all of this to Splunk. And what we saw, the first phase, we didn't know there was going to be multiple phases. But the first phase was, we saw that by doing things like powering down unused ports, by moving workloads to different circuits, we could actually have energy savings. The easiest thing for people is to say, hey, just upgrade, migrate from an ASR to a Cisco 8000. You're going to have all these new features and energy utilization, but we know you can't instantly do that. So what they saw from the recommendations that came out of the insights in Splunk was, you have a lot of ports that are powered on, but they're not used. You should power these down. But what are on these ports? Are there circuits that we can look at as well? So what we did, in addition to continually looking at the energy consumption, we started to look at what's on these ports. We started to look at the network, and the use case there was, I have 3 circuits. Is there a circuit I can power down at night from, say, 2 in the morning till 6 in the morning if there's low traffic? But I just don't want to pick a random time frame. I need to see if I can really do that. So we collected utilization data. We had something called WAN acceleration engine that we tied into Splunk as well. And that showed us that certain time of the day, from 1 a.m. to 6 a.m., the utilization went down. Now, we didn't want to look at it and say, well, we're going to keep that forever. We continued to collect information. And if the traffic started to pick up earlier, we tied it into an automation pipeline where it brought that circuit back up. So they rolled that out in one site, and now they're looking at all of their other different data centers. So we started small, and now we're actually starting to roll it out. And one of the things we did see in this data center, by changing some of the port configurations, by migrating applications, they actually saved $500,000 in 1 year from costs, and cost was key with them. Yeah. So with that said, thank you all for joining our session. Please feel free to go ahead and fill out the survey. If you fill out 4 surveys, you can get a T-shirt on Thursday, and it's all in the events mobile app. If you have any questions for us after as well, please feel free to drop by. Thank you all. Oh, and some great sessions. If you want to see real demos, Splunk and the CX booth as well. They show what we're doing out there, especially with XDR as well. All right. Thank you.
Thank you.
Okay. Hello, folks. Welcome to the session. So how are you feeling today? All good? So smells like the lunch is coming. So let's try to have this kind of the session compact. And raise a hand if you are attended like more than 3 sessions today already? No? Yes? I did like 4 labs already, but I was just supporting them. So that's how it goes. So welcome. Today we're going to talk through the AI-driven transformation in Cisco secure firewall operations. And first of all, my name is Dmytro Kontsevyi. I am a content developer in Cisco the Cloud. And out of curiosity, did you hear about Cisco the Cloud before? Most probably not. So we are like keeping all the, let's say, demo environments, and there are plenty of like hands-on labs and walk-in labs and CTFs are happening. And most probably, like, I'm very passionate about demos. So if this kind of the content is going to be like interesting, then we'll bring like a labs and the real environment, which will include the things which we are going to discuss today. But before we are going to get into the details of the today's session, so first of all, what do we imagine? Like, what's the first thing which is coming to our mind when we hear like AI and operations coming together? So ideally, it has to be like some sort of the product or solution which is going to like resolve the challenges itself, right? Ideal situation. So I wish I can have the one kind of the product like this available. But before we are going to reach out to this point, then the products and solutions are going to like resolve the challenges themselves. Like the initial stage is probably that we want to get some sort of the actionable insights. And based on this insight, we are going then to take a decision. Okay, I want to have a remediation. I want to actually remediate this actually challenge happening at this moment. And then I can go through the process, get inside the tool, get alert, and then I can get this one result. Or maybe when I was like starting the IT career, it was like very common thing that I want to have a make me a coffee button inside like the product, and you just click and then you are getting. So probably this is one of the best features which might be coming around. So as this session is going to be like pretty compact, we are going to check next 4 main things. So we are going just to find the baseline for where this AI and Cisco world stands about. And then we are going to switch our gears to the AI ops, just actually itself as the term, with getting a focus on the secure firewall. And then we're going to check like a dedicated features which are available today. So there are like 2 main features, which is AI assistant and IOPS insights. This session is not going to be focused on stuff around security, because you probably was able to see like the secure firewall and operations and AI like as a words coming together in a title. But actually we are not going to talk about like how the inside the product we are going to detect something. So how we can like combat some specific threats inside the product. Or for example, we have like a snort machine learning signatures now available in the firewall, right? So this is something out of scope of this presentation, and the security for AI itself is out of scope. So we are going to get just focused only on the operational side. And I wanted to make this session like as a cheat sheet for myself and for everyone, like for my colleagues as well, and for everyone who will be willing to just get some, let's say, some basic information and come on with its own use cases and its own like requirements for the AI operations. So before we are jumping into the AIOps feature itself, let's take a look at the, let's say, the entry level from where is it all comes from. So we know that today there are so many business drivers for AI. There are so many kind of the deployment strategies. And Cisco is about to support you into any kind of the journey around this kind of the, let's say, pillars. And the main pillars which are going to, like, where the Cisco is about to support you is, first of all, like you probably heard about, like the infrastructure piece. So Cisco provides actually the AI-ready infrastructure to meet any kind of the, like, let's say, needs. Security for AI, and as we might be able to see, like in a blue, like what we are going to get focused on is actually the AI-powered software. So the product, the solution, is about to include AI inside to grab the data and provide some kind of the meaningful insights for us. And of course, the last one pillar, which is available here, the Cisco is about to accelerate AI value and might be trying to suggest like the correct one solutions. So when we take this actually AI-powered software and data piece, we might be then trying to like see in more details that for this to work and to answer the question what, actually here we might be able to see that AI native solution. So the product itself is about to have the AI integrated inside, and we might be having then this product with correlating the data, and we might be able to get this kind of the analytics and insights provided for us. And what kind of the AI unified management do we have right now, which is about to provide the answer to this question? Who might be remembering? So we have Security Cloud Control. So the legacy name is CDO, and the Security Cloud Control is now AI native unified management for any environment, and primarily like for the security products. And now when we know like the main focus, let's try to answer the next one question, like why do we need this? And one of the like answers for the why question is going to be that, okay, we want to have the AI operations. So we want our products actually to be able to suggest the fixes and detect like issues more like proactively, even before the issue actually happened. And the term itself was primarily actually introduced by Gartner. And we might be able to see that it combines like big data and machine learning actually to automate IT operations and processes. But more simpler is to imagine it rather than like a platform, or even better, like the approach of how we are trying to modernize the IT with using the AI helping us with this. And then we might be having like different kind of the benefits available with which are coming with the AI operations, and those benefits might be including. So we have like the, let's say, bridging skill gaps. So there might be like a more junior, for example, admins available who might need some sort of the assistance in how to get something configured on the firewall. We also might be getting some sort of the recommendations around the best practices. So what kind of the best practices has to be activated. So what kind of the features, like a feature adoption piece, which might be suggestion. And of course, this kind of the data analysis piece, which is going to getting through all the events and logs. This is how we might be able to get some kind of the actionable items. And this all is going to provide us the access to next AIOps use cases. So we want to get the intelligent alerting. So we want to get the alerts, and ideally before something is going to happen. We want to get some sort of the smart event correlation, like when multiple things are getting to happen. And we want to see the forecasting and prediction, and also we want to see like the solution. So it's not only like we are getting alert and then we have to decide by ourselves what to do with this alert, or we are getting some kind of the forecasting that, okay, the VPN users are getting increased and probably we will reach the limit, and then the users will not be able to actually get connected. So we have to get like more licenses, or maybe traffic get routed to another one firewall. So, or another one fundamental piece here might be like the policy analysis factor. So we can have a firewall policy with plenty of the rules inside, and we know that there are multiple teams and admins, they're managing this kind of the policy, then there might be like messy in some time. And then we want this policy just to get like reorganized, restructured, and reconfigured. So we want not only get the alert, but we want to get like the actionable remediation for this. And ideally, the ideal one point will be to get like a self-remediation, like after actually, like when it's possible. So the overall process and the flow for the AI ops will look like that we are getting actually something detected, diagnosed as a problem, getting the alert. So there might be the integration done with some ticketing system. And of course, they're going to be provided like a remediation solution. So we can get through the remediation steps, and following those kind of the steps, we are going to get the issue fixed. Behind all of these steps, what kind of the main components might be included? You see, there are so many of them, but actually, let's say the more fundamental pieces, we are getting data analyzed with the help of the AI and machine learning. And we also getting this kind of the NLP, natural language processing possibility too, to be able to communicate with our firewall management system and get the actionable results. And so we answered like two main questions, like what? So we have like a secure cloud control as the main like system which will be able to run the AI to process the data. We discussed why we need this, because we want to have like to be more successful in terms of operations. And then now we're going to answer the question, how are we going to do this? And we have like a two main features available, which is the AI assistant and AIOps insights. So raise your hand if you already worked with the AI assistant in your environment in any way. So have you ever touched this? How successful was your? So, and as I mentioned, like I'm kind of a little bit like passionate around demos, so we will try to get through the demo right now, just opening a dashboard and see like behavior and what's going on here. So AI assistant provides us this kind of the conversational interaction with the product. So we might be able to provide actionable kind of the questions to get some sort of the insights about like what we have configured at this particular moment, get some stuff around our policies, and we also might be asking like to get the things done just using the AI assistant. So we can ask like, okay, can we create a rule for specific one user or rule for the specific one IP address? And all this requires like, there are like specific one prerequisites, and the main prerequisites just include the connectivity. So there should be integration with the Cisco Secure Cloud done already. And there we should be having the specific one user roles. So it depends, like we can run for both like on-prem or cloud-based FMC. And here you might be able to see that for cloud control, we need to have like super administrator or administrator, or for the on-prem, just global domain admin. And the station from which we are accessing the existing one management system should be having the internet access. The main functionalities around AI assistant includes the next 5 items. So we might be getting the help with the documentation. So we might be asking a question, okay, how can I configure the access control policy, for example? We might be getting the updates around our own policy insights. So it might be possible to ask like, okay, so which one rule is blocking like application box, for example? And also it might be possible to ask like, okay, do I have any issues inside my firewall policy itself, and how I can get it improved? So those are, let's say, like first main points around how the things might be, how we can communicate with the firewall management. And then also, we might be running the chat like in terms that we can get the information and status updates around the cases we have. We might be getting the cases opened with tag just through the AI assistant. And also we have a dedicated notification center here. So if we try to take a look at the specific one examples of the actually around the online help documentation hints, then here, and let's take it out, and I want to actually switch. Let's see if it's going to work. So switching to the dashboard, we have Security Cloud Control dashboard available here. So we have the AI assistant available there, and we might be willing, so this is like a regular kind of the, let's say, Gen AI kind of the communication when we might be able to ask a question. And for example, I'm going to ask, can you guide me through configuring a new secure firewall policy on the FTD? And I expect to get some meaningful result there. So actually, what is it cool that this kind of the information is going to be mixed with the best practices depending on the context, and you might be getting like a more hints. Because for example, you might be saying that, okay, so it might be possible to get like documentation open, but we know that nowadays there are so many sources and there are so many places where like the different things might be getting described. So for you to be able to get like a quick info about how to get something configured and how to get something done, you might be able to communicate with the AI assistant and trying to get like more details here. Also, for example, like another one tricky thing for the secure firewall might be related to the traffic processing. We have like a multiple policies in place, and we might be then like, okay, so we have the information. So, oops, just let me switch to the, we got the online help section. And for example, Another one, kind of the question which we might be getting raised here, can be related to like what is the order of how different policies being applied on FTD. We know like a pre-filter, security intelligence, SSL decryption, and so on, like access control policy and then IPS and file inspections. So this kind of the question, which might be like kind of challenging, like at least for the guys who are starting, like communicating, like starting this journey around the secure firewall, then you might be getting this one quickly addressed directly through the AI assistant. And what is the cool thing that you might be then navigating and you might be able to see this kind of the replies, and at the same time you might be able to get through the policies, navigate around and get the full picture and an understanding actually of what's happening there. So the category for the AI assistant around the online help documentation is pretty cool, around like filling these gaps for a skill set of the admins. And the next one is going to be about the main block is about the policy insights. So we might be getting like the actionable kind of the questions addressed here. And for example, I know the demo when my colleague configured something, and now I probably have to troubleshoot and run some kind of the packet captures on the different interfaces. I might be like checking different kind of the policies and tons of rules available on the policies, just trying to understand if the traffic is permitted or denied for the specific one IP address. Instead of doing this, in this context, I can, for example, just raise the query, like which rules are associated with the IP address. And then as easy as it is, I can be getting like the reply that, okay, so depending on the policies configured, because we might be having the cloud-based FMC and we might be having the on-prem FMC integrated here. So depending on the context, we also might be getting the information about, okay, so I have the two rules associated, and then I can ask more, like show me what is the policy, for example, related to those kind of the specific rules. So that's how we might be easily able to get the policy insights information. And the next one thing that we are not even like asking like for the specific items, then we also might be like requesting the system to do the policy optimization. So we can raise the questions like identify any inconsistencies. So we might be willing to see like, okay, so if my rules are structured correctly, for example, and do I have any kind of the overlapping rules? Do I have a shadowed rules when like more, because there are like some common best practices available for the firewalls when actually we have to put like more specific things on a top, above more generic ones, and so on. So there are like common approaches, but you know, with the different environments, it might be very hard to manage. So we can just easily share the request and say like, okay, so please help me to get the policies optimized, and we can get the suggestions around what's going to be like happening and what kind of the suggestions are going to be available here. And the next major pillar, so we also might be able to do the, let's say the configurational piece, plus we might be very easily and flexibly be able to communicate with like around what kind of the support cases we have at this moment, and communicate for the opening the support case immediately. So as you were able to see through all these core steps, we have a possibility to actually identify the current status around the policies. We might be able to also get the quick one hints like what's available in the documentation and inside the best practices, and immediately like open the support ticket. So this is kind of closing this kind of the circle around the AI operations story. And that's all we might be able to easily manage from the perspective of the AI assistant. So the main requests, you will have them actually shared in a slide deck. And then if you require more, there is a dedicated guide how to build those kind of the queries properly available. And the next one, pillar, which is going to take care about all the AI operational story for the secure firewall. This feature has named IOPS Insights. And this feature is going to be like a more advanced in terms of what's going to be available for the administrators. So with this feature, you also might be having like this touch and feel for the policy anomaly detection, so which is available inside the AI assistant. But with this feature, you're going to see more detailed description of how the situation around like the policy and your rules configured looks like at this specific moment. And then you might be able to follow the remediation steps of getting the things fixed. So how it looks, if we just get to the dashboard, we might be able to navigate to the policy analyzer and optimizer. And this tab is going to show us, like, so we might be able to pick up between like a cloud managed FMC and on-prem FMC, and then we might be able to see like what kind of the anomalies from the perspective of the policies available. So for example, I want to pick up my on-prem FMC, which is running now in some kind of the environment, and I might be able to see what kind of the access control policies are having issues at this moment. And I'm getting the real, like, kind of the suggestions, like, hey, so those are the anomalies. So we might be having some shadowed rules when one more generic rule comes before some specific rules. You might be having like a redundant rules, and the redundant actually they are coming behind these more generic, or suggestions for the mergeable objects or overlapping objects themselves. And what is cool here that we might be able to see like immediately the analysis done for the policy, and we might be able to run the actions. So we can get a more detailed report about, okay, so I want now to know what kind of the rules here, which are provided. Or I might be just clicking here, and I might be then, for example, I might be able to see the full details about specific one rules, what those rules are, and then I can immediately take the action. So I can disable those rules, I can get those rules deleted, again, download the report, and then I can get back in time just when it comes to the analysis of what kind of the actions were done. So with the AI assistant, we also might be able to get this kind of the flavor and this kind of the data, but more detailed, we are going to get this visible inside the policy analyzer and optimizer. And in the same way, this AIOps Insights includes, first of all, like there is going to be the summary dashboard available as well, which is going to show what kind of the insights are available. So the insights, for example, by the activity, by the traffic, which is going to be flowing through the firewall, for example, or this VPN. So we might be able to see the categories like a traffic and capacity, health and operations. And then we can get those insights here listed based on severity and actually different kind of the factors here. And then we can do the actionable results. So then we can do in the same way like we had it for the policy. I want to get the stuff fixed. On the top of this, there are like two other main categories available. So one is best practices and recommendations, which is probably like another pretty demanding thing when we want to get the insights of what's happening and what's configured, what's not configured in our system. And feature adoption is probably the more interesting thing, because we might be able to see like what are the core features we might be having enabled, and actually how to get them enabled with the more details about like feature recommendations provided from the same one dashboard. So with that being said, like we just review like 3 main pillars from the AI operational perspective for the secure firewall. Yeah. Up.
Can it provide help with configurations?
With a configuration like for the policy. Yeah, so there might be. Yeah, so we might be able to. Yeah, so there is available the possibility for the actually for the configurations, but I think we can take it just after the session and discuss. So it's unfortunately I got the notification it's time is over. So just to summarize the things up, we discussed like so we have this AI-powered software and data which is included inside the Cisco Security Cloud Control. So what is a platform which is going to provide this for us? And even if when we have like a on-prem FMC still has to be integrated with the cloud control to get the AI assistant feature enabled. Then we answered why. So we need to get like the actionable insights around what's happening in our environment and how we can get this one result, and how it's included in 2 main features, which are AI Assistant and IOPS Insights. So thank you, and enjoy the lunch.
Okay. Can you hear me? Is that good? Everybody can hear it? So the bad news is our clicker is broken this morning, so I'll have to stand here. But you can still see the slides, and I'm here. Anything, just let me know, all right? So thank you for being here, and thank you for this opportunity to present to you the certification portfolio updates that we have. My name is Mubasher Nawaz. I'm the portfolio manager for all the certification programs. One of my responsibilities is to make sure that we keep our certifications up to date with all the changes that are needed. And there's a lot of exciting news that I have for you to be shared here. So when I woke up this morning, I saw an interview of our Chief Product Officer, Jitu Patel, with some news agency, and he was talking about we need to be bold with AI. We need to make sure that we go out and do these things that nobody is willing to do, right? At the same time, I was thinking that I read a Gartner report a few days back where it mentioned that 40% of the organizations feel that we are lacking all these skills and trainings that we need to provide to our employees to get them to that point where they are ready for this change that AI is bringing in our lives, okay? So with that in mind, we are, for last few years, what we are trying to do is to keep our certification roadmaps focused in building those skills that are needed today in the market and the ones that are going to be needed tomorrow in the market. There are a lot of job roles that do not even exist today, and there will be a lot of job roles that will not exist in tomorrow, okay? So keeping that in mind, when I'm developing these strategies, I'm trying to make sure that our Cisco certification program is up to date with all these changes, and we are developing those skills that are needed for the employees of the future, okay? So our certification life cycle revolves around a few things. Number one, it's annual. We want to be very agile with these things. It's iterative, and we want to make sure that our portfolio is up to date and includes all these new things. This helps us align with the rapid technology evolution, especially happening with the AI right now around us. It also keeps our programs relevant to our customers. And we not only add new stuff to our programs, we also get rid of anything obsolete that we do not need anymore in our certifications. One of the things that we got a really good feedback was that it's really predictable. Now, if I'm preparing right now for my CCIE exam, I will know when the next change is possible to come, right? And if it doesn't come at that time, I will have some time after that to do that. I'll go in more details how we do this thing. This is our certification roadmaps. This is how we do it. So every quarter, we have a task that we have to achieve. So either we are reviewing something, or we are announcing something, or we are publishing some blueprints, okay? We start with data center and collaboration, and then we go on to enterprise and DevNet, CCNA service providers, security, and cyber ops. And when I say about these things, I'm also talking about our professional level exams, our expert level exams. Everything fits into this cycle, okay? Now, for some exams, we do need more time. Like expert level exams, we might need 6 months. For professional level exams, we might do it in 3 months. So it all depends on how much time do we have at that point. Now, revision framework is, so there's two kinds of revisions we do. One is major revision and one is minor revisions. So major revision, if you just want to simply remember it, it's a number change from 2.1 to 3.0. Usually, it's a large set of revisions, major changes, steep learning curve, and wider alignment to our products and technologies that is happening. In the minor revisions, we try to do smaller modular changes, incremental changes, bite-sized changes, so that we can kind of accommodate we can meet you guys in your learning path. So let's say I was preparing, and and suddenly Cisco announces, oh, we are going to release a new version of data center exams, okay? Now, I don't want you guys to say, oh man, I was preparing for last 6-7 months, and now I have to stop my learning because Cisco has released a new version, right? So with modular changes, minor changes, we have this opportunity that changes are so minor that if you are in the process of learning, you continue your process of learning, and you will still be able to achieve a successful pass score if you continue that. Now, with the blueprint revision framework, there is different things to notice. I'll focus on some of them. So for example, the hardware and equipment model change. So if it's a CCIE exam and we are doing a minor revision update, we are not going to change the hardware and softwares in that. But if it's a major revision, we will change the software, hardware as needed, because there's a lot of new hardware coming right now in data center and other technologies. We will have to do that. The important thing is the announcement. So for major revisions, we usually give at least 6 months. It can be more than that. It can be 8, it can be 10. For minor revisions, we give 3 months for associate and professionals, and 6 months for the expert level exams. Now, let's talk about certification roadmap. So what actually changes? How do I identify which version to read, right? Number one, I'll have a link at the end of this slide deck for the roadmap. So I would recommend going to that for any updated information. Also look at the increments on the version number. So are you reading version 1.1? Are you reading version 1.2? Which version of the exam are you preparing for? Okay, so be ready for that one. Minor blueprint revisions are less than 20%. So if you think about it, and if I give you a ballpark number, let's say passing rate is 70% or 80%. So those 20% should not affect your decision on passing and failing, but you should still learn for it. Maybe that's the one question that's going to get you through this one, okay? Software versions, wherever needed, will be upgraded. So what does not change? So in previous years, we used to update our exam numbers. So our candidates were confused. Oh, I was preparing for CCNA 200 101. What is this 301 right now, right? So we have stopped doing that. We do not change exam numbers. They remain same. We only have version numbers in front of them now. So you should be able to identify easily which version you have to prepare for. Again, announcements are 3 months for associate and 6 months for the expert level exams. With this new process, now we also provide you with a lot of resources. So the best resource that we give you is release notes. I highly recommend anybody preparing for exams to look at these release notes. They give you a comparison between your version 1.1 and version 1.2. So what's the difference in two versions? So you can say, okay, task 1.1 is changed from this to this, and you can easily identify how much effect it's going to have on your exam. Okay, so release notes is a very good one. It also provides you a summary and the side-by-side version of that. We also provide you the learning matrix. Now, learning matrix is a very good resource if you want to see how do I prepare for CCNA exam. I want to learn, but I do not want to go and spend so much money on different trainings and boot camps and books and this and that. How do I start my learning process? So you start your learning process by looking at this learning matrix to start with, and by going to Cisco U to see what's available there already. There's a myth out there that Cisco U, you have to pay a lot of money to get access to. A lot of stuff is free in there. A lot of tutorials are free. A lot of trainings are free. I have a training over here that I'll show you that is freely available right now. Okay? It's going to give you C credits if you want to recertify. So use those opportunities to learn about your exam, whatever exam you are preparing for. So to provide you with a 1,000-foot view how Cisco certifications looks like as of today, if you look at vertically, we have kind of divided them into 3 categories. So we have engineering, software, and cybersecurity category. And if you go into this direction, you have entry, associate, specialist, professionals, and expert level certifications. Now, all of these work streams we have different kind of initiatives. So this is focused on engineering, very famous. A lot of people do that. A lot of software engineers do this one. If you are into cybersecurity, people do that a lot. We don't have a cybersecurity expert right now, but we are in discussions to see if we need to have one there, right? So moving on. Now, let's focus on the first one, which is the CCNA one. So these are all the exams that you have available today. There are 5 technologies that we focus on. So we have enterprise, security, service provider, collaboration, and data center in the first one. And then we have DevNet and the cybersecurity one over here. So each technology has a core exam. So you have a core exam, you have a core exam here, okay? And then you have all these concentrations you can choose from. Now this core exam over here also applies to your expert level exams. So if you pass your core exam, you can also book your lab exams for your CCIE or any other lab exam that you want to give. And if you pass one of these concentration exams over here, what we call as 1+1 formula, so you get your CCNP certification by doing your core and one of the concentration exams, and in any of these tracks, okay? So you can do DevNet, and you can do this, and you get your DevNet CCNP, DevNet professional exam. If you do this one and this one, you get your data center professional exam. And you can also book your CCI lab exam from there onwards. Okay. So let's start with our upcoming and new learning AI solutions path that we have recently released, which is called as the AI Solutions on Cisco Infrastructure Essentials. Now this training is now available for free to you guys to rev up for your research process. You can take this course until March 24th, 2025, and you can earn 34 CE credits. Now, you need 30 CE credits to recertify your associate level programs. So if you do this one training now, you get 34 CE credits for free. Okay? Just do it by March 24th. That's it. This training is really good if you want to gain the knowledge for deploying, migrating, and operating AI solutions on Cisco data center infrastructure. It also gets you ready for any professional level job in data center environment. There are no prerequisites for this. It covers a wide range of AI topics in it. So if you are someone who has a certification today and you want to recertify using CE credits, I highly recommend using this one, and it's free. Just do that and get free 34 credits. All right? Cisco Modeling Labs, again, a very premier platform for network simulation with an easy-to-use user interface and comprehensive API. CML makes it really fun to design, troubleshoot, and learn new topologies. You can customize your setup as needed with unmanaged switches and external connectors as you need. It's available for free. Anybody can use it now. You can, in fact, the whole enterprise exam can be created in your CML. You can do SP stuff in it. You can do security stuff in it now. So there's a lot of things that have been added. I highly recommend if you want to use this one. There's smart annotations to quickly create organized topologies. Next generation firewall enablement is there now. Custom MAC addressing is there now. And it's an essential tool if you want to learn for any practical exam or any labs that you want to do. Okay? Now, let's look at the CCT certification. So we recently did a very big change in our CCT portfolio. It represents a significant shift from the previous model that we had for CCT. We used to have 3 exams in CCT. We have finished those 3 exams. Now we only have 1 exam, and that exam is called as supporting Cisco devices for field technicians. We already have a new training, version 1.0, available to you guys. So it has several advantages with reduced timings from 25 hours to 10 hours now. It has a lot of interactive learning items now added to it for learning purposes and to retain all that knowledge that you need for CCTE program. The exam is also different, so you do not have to do 3 90 minutes exams. You only need to do one 20-minute exam. It has 100 questions in it, so it's a very straightforward exam. So something really big that we did recently, it's already live. If you have somebody who's going out to customer sites to do deployment and cabling and racking and stacking, we highly recommend doing this one. So with cybersecurity, we did an announcement a few days ago where we were like, with our commitment to the cybersecurity and the AI's role in the cybersecurity field, effective January 21st, 2025, we have changed our cyber ops exams to cybersecurity exams now. So all of our portfolio for the cybersecurity cyber ops is now called cybersecurity because we are expanding how it will be in future. The track itself will be updated from cyber ops to cybersecurity along with the cyber ops associate, which now will be called as cybersecurity associate. And it has been updated from version 1.1 to version 1.2. The new exams are now available for you to test since January 21st. Similar to what we did with Cybersecurity Associate program, we also updated our professional level exams from Cyber Associate to, from Cyber Ops Professional to Cyber Security Professional exams. Again, some of the exams in there are not updated. For example, the threat hunting exam is still version 1.0. The core and forensic analysis and incident response is updated from 1.1 to 1.2. The new exams are now available to you since January 21st, so you can go and test on the new cybersecurity professional exams. Another big announcement that we did on February 9th, like 2 days ago, was around the fact that we have made a change in our CCDE program. Previously, when you used to pass your CCDE written exam, you used to get a specialist badge. That's it. And if you pass your lab exam, you used to get a CCDE badge, and that's it. Now, what we have changed now is that we have built in new badges for each step of your path where you are. So if you pass your written exam now for CCDE, you are going to get a CCDE Expert Specialist badge. So we have distinguished you from all the other specialist badges that we have. And after that, if you pass the lab exam, we also give you not only the CCDE badge, we also give you the specialist badge that you chose from. So you have 4 things. You can get workforce mobility or the new one, the AI infrastructure one, the on-prem cloud or the large-scale networks. Whichever elective you choose, you get a special badge for that one. Okay, so it's all on your side, how the CCD program is. Once you select the elective, you get, and you pass that exam, you get a new badge. So you have a badge for your written, which is an expert specialist. You have a badge for your CCDE, and you have a badge for the elective that you chose. So starting February 9th, so 2 days ago, we had the first offering for the AI infrastructure exam for the CCDE that we did. It's a game changer for the IT professionals seeking to harness the power of AI. By passing this elective, you gain the knowledge of designing, building, and ensuring that your design is robust and scalable networks and can handle the demands of the AI workloads that are needed. Ensuring the AI networks are secure and in compliance with the customer infrastructure design needs. We have free AI training and tutorials available now at Cisco U, so I highly recommend all of you to go and look at those trainings and tutorials that we have for you over there. We recently announced the update to our data center exam portfolio, and it has been updated to align with the current AI enabling network technologies. The exam topics are now available for you to have a look in the certification roadmaps page. The exam is going to be available from 21st of May, 2025. You can use this QR code to look at the blueprint, what changes are coming into that. Or if you don't want to use that, I'll recommend going to the roadmaps page. I'll have the link in the end to look what are the changes that are coming up in data center exam. SDSI is, no. My laptop wants to go more faster than me, and I still have 10 minutes. The exam certifies a candidate's knowledge for security architecture. So if you are into security domain, this is a very good design exam that we have that we announced a few days ago. It's going to be available on May 20th, 2025. So you can register with Pearson VUE and get this exam done. Now, this exam covers the security architecture, design, including securing infrastructures, application, risks, events, requirements, artificial intelligence, automation, and DevSecOps. Holders of this certification will be able to identify organizational assets to be protected and assess current security measures and associated vulnerabilities. As I said, the exam is going to be available on May 20th. This is the QR code if you are interested to look at the exam topics, and it's also available on the roadmaps page. So Cisco certificate in ethical hacking, which we announced in last year in October 8th, 2024. This is the first certificate that we have ever announced. Before that, we only had certifications. This is a kind of a entry level, I would say, where you have to do this. I have a map where I can show where it falls. It tests your knowledge on ethical hacking basics, penetration testing, red team tactics, and advanced threat response. How do I get this certificate, right? So it's very simple. You go to netacad.com and complete the free Cisco ethical hacking course. It's free. You can just do the course. Once you do the course, download the challenge topics from cisco.com, ethical hacker landing page. Go to Cisco U and sign up for Capture the Flag. You have to pay us some amount for this. It's a very minor amount, very small. Pass your first challenge and earn your Cisco certificate in ethical hacking and badge, and get the new challenge every 9 weeks. Now the news is, these two, DNS Event and Wireshark Foo, are only available till today. Okay, so they were up for 90 days. They're going to expire today. But if you buy them today, you will have 90 days to finish these tasks. Okay, so it's last date today. But if you do it today, you buy them, you will have 90 days to attempt these capture the flags. Okay, now these ones are going. What do we have as a replacement for them? So this is what is coming out tomorrow. Not this, this. Go back. Okay. So we have a new task that is coming out tomorrow. It's already ready. I have seen it. It's a totally new capture the flag that we are releasing tomorrow. Again, it's going to be available for another 90 days. We will be releasing another one in between, which will again be available for another 90 days. And every 90 days, you have a new capture the flag, which you can earn and get your respective badge. So similar to this one, you can get a badge every time a new capture the flag is released. Okay? But you just need to follow these steps to get through the training. And then after that, you just buy new capture the flags every time. And you can continue collecting these new badges that are coming up. Now, if you look at the whole security portfolio that we are offering right now, so we have CCST cybersecurity, we have the associate level exams, that's where ethical hacking sits. We have professional, and we have the expert level CCIE security available to you as a whole set of end-to-end security portfolio that you can use. Okay, that's the landing page. I highly recommend everyone to go to this page if you want to get the latest information on what's happening with Cisco's certification program. We post everything over there. Any update, any dates, any announcement that are coming up, everything is posted over there. And if you have not already done this, this is the opportunity for you to do it. So make sure. I hope one day it will listen to me. Okay. So you can save 50% on your Cisco certification exams. So you get one free exam if you have pre-registered during your registration process. You can do that. If you have not done that, you still have opportunity to do a 50% discount on any of your exams. So one free, 150% exam. We have in Hall 5 on the left side. If you go out and on the left, we have the testing center. I would highly recommend if you want to do any of your exams, just go and do it now. This is a great opportunity. Get discounted price and do your exams over here at Cisco Live. This is the WebEx app. I will be there till February 28th. If you have any questions, which I do not answer right now, please post them over there in that WebEx space, and I will be happy to answer them. And if you give me good scores, you get a free T-shirt. See? That's what we do. But now, jokes apart, you can do 4 session surveys, and you get a T-shirt, and and you have to finish it by 11:30 on Thursday. Okay. So use your mobile app to do these surveys. Do not stop your learning. There's a lot of good stuff happening right now. We have DevNet stuff going on there. We have LNC stuff going on here. There's a lot of sessions happening in this theater. We have these booths over here, and there's a lot of people out there which have great opportunities for you to learn something new. I would recommend going to these demos and set up a Meet the Engineer if you want to. Do the Capture the Flag. Walk-in labs are really awesome over there. Capture the Flag. Every time you do Capture the Flag, you get new C credits. So you can repeat it 100 times. You will get 100 credits. Doesn't matter. On-demand library is going to be available, and this session is going to be available from March 3rd onwards. And thank you very much. Is there any questions I can answer? Yes. So Cisco Press. So that's a very good question. How do we make sure that Cisco Press books are updated, right? So we are in very close collaboration with Cisco Press. So even before we announce anything publicly, we do meet up with them. We make sure that they are comfortable in updating their books. Most of the time, they are updating their online versions immediately. So they get the content ready, and they get it ready even before the exam goes live. Okay, we try to achieve that. Sometimes it's not possible, right? But we are in very close contact with them to make sure that books get updated. Exact dates for those, I would say if you go to Cisco Press people in Cisco store, they should be able to answer it. But we are in very close collaboration with them. We make sure every content, all the trainings, anything that needs to be updated is updated with the latest information. Okay? Any other questions? Yes, please.
Are there any ideas or plans to integrate the black belt program into this program?
Okay, good question. Yeah, so we have different programs that exist. So we have black belt programs and other things that exist out there. Right now, we don't have any plans for that, but yes, we are looking into it. At the end of the day, what we want to do is to give a holistic experience of learning and training from one platform to everybody. It might happen in future. I don't have any concrete dates to share right now, okay? But yes, maybe at some point we will do that, okay? Any other questions?
When Cisco puts the exam topics on the website, the blueprint, is there anywhere where they also list the white papers that align to all of the exam topics? Because I just always struggle to find the white papers that align to all the topics.
Yes, so as I said, so the question is when Cisco publishes the new blueprints, do we update any resources that are needed with it, like white papers and other stuff, right? So in the release notes, in the learning matrix, we have a list of Excel sheet which corresponds with each topic and subtopic and what to study to learn that subtopic. So it might be a book reference, it might be a Cisco Live session, it might be a white paper, or it might be something else. But that learning matrix has all the information you need to prepare for any exams, okay? So you look at the learning matrix, and then it will give you all the information you need to prepare for your exam, okay? Any other questions? Who's going to appear in an exam over here? Yes, please.
I'm not doing an exam, but a question about the learning matrix.
Yes.
Do you have that from each certification type, like collaboration, enterprise networking?
Okay.
Because I've searched for it, and it seems like some learning matrix are missing.
So the question is, do we have it for every certification out there, right? For all the core exams, for CCNA and for CCIE, we have learning matrix available. All right, they should be available on their on the website, on their pages. Some of the concentrations also have it. Some of them do not have it. I know that, right? So, but it does exist for most of them. In fact, all the core CCNA and CCIE exams they should have a learning matrix available. All right. Good. Any other questions? Yes. Sorry, say again? Yes.
Which level are we expected to do? Is for CCNGE already certified person, or it's for someone?
It's a professional. Okay, so the question is, what is the level of SDSI? So it's in the security domain, and it's a professional level concentration exam. Okay, so that's the level we are looking here. It's a new exam. Obviously, there's a lot of questions around it right now. We are not looking for somebody to have a CCDE to do that. It's at a professional level. At the end of the day, you will see that how we transform this. We will have some design exams at professional, and then we have this expert design solution that we provide right now. So that's the train we are trying to go with. Okay? Anything else? No? All right. I hope all of you do an exam here at least. It's a free exam, and you have discounted exams as well, 50%. Best of luck to all of you. Okay? Thank you very much for listening.
All right. Can y'all hear me okay? Excellent. Welcome to the Cisco U Theater. We're going to get started in just a minute with today's session, but I'm here to warm up the crowd before the actual presenter shows up. I'm the actual presenter. That's the first joke. It's how I gauge how well things are going to go. So far, looking good as it goes through. Are you enjoying Cisco Live so far? Yeah? Excellent. How many people how many people are suffering from jet lag? Just me? Yeah, the Americans. It's good. This is the day, like the number of days travel, this is the roughest one for me, which is why I always book it solid with stuff to do. So otherwise, if I sit down, I end up falling asleep behind a tree someplace, and then someone has to come find me, and that never goes over well. And so I just keep myself busy one session after another, and I'm really excited to talk about today's session here. I'm not sure if anybody's aware of it, but there's this new kind of innovative thing that's been happening. It's just in the corners of the IT world, and it's starting to kind of gain some steam called artificial intelligence. Have you heard about that at all? I mean, clearly, I'm the first person to mention that to you here at Cisco Live in Amsterdam, right? Yeah. That's good. You came here for the latest about artificial intelligence, and I appreciate your dedication. Now, artificial intelligence is not necessarily new. We're seeing all over the place different use cases inside Cisco, outside Cisco. I think everybody's trying to figure out what artificial intelligence is going to mean for them and their business and their customer interactions. And we're no different here at Cisco. And I had the luxury to kind of put my own spin on it, my approach to kind of consider how artificial intelligence might factor in to different aspects of network engineering. And I live in kind of this world of technical education, helping people understand technology. And so that's the approach I took at it. And we're going to look at it here in today's session, creating an experimental CCNA mentored chatbot as I explore some AI possibilities. My name is Preston. I'm a principal engineer here at Learning and Certification, and I started dabbling in kind of the software space and networking around network automation, and I was really excited to see how things could grow as we bring artificial intelligence into the place. And so what are we going to talk about in today's session? Well, we're going to talk about why would I, Hank, who loves to teach people about technology, build an AI-powered CCNI mentor bot. So we'll hit that in just a second. Then we're going to spend quite a bit of time, because I want to show you kind of what I found was possible and what we're looking, and I want to stress, this is a prototype concept. This is not something that's yet shipping, though I'm hopeful that we'll see this kind of grow into capabilities and offers that we offer here from Learning and Certifications and Network Academy for our students. But I do want to show off in a demonstration kind of how it works, and it's as live as it can go, so hopefully you all bear with me as the artificial intelligence gremlins all kind of dive in at us. We'll explore that together. I'll then spend a little bit of time kind of talking about the components that we had to pull together to make all of this work. Right? There's lots of different ways to build AI architectures and AI applications, and this is just one. It is by far not the right way to do it or the best way. It's just kind of the approach I took as I've been exploring. After that, I mentioned we're looking at a prototype, so I'm trying to think about what might come next with this as this potentially moves forward into an actual product from our team here at Learning and Certifications. And then I've got questions at the end, but feel free, if you've got questions during, feel free to ask. If I can't answer it, I'll ask the AI mentor bot and see if they can answer your question. So, first up, why did I decide to look at building an AI mentor bot? And it really comes down to kind of one specific piece of information. There are a lot of you and only one of me, right? I think we can all agree on that. I mean, I just look around here and there's a lot of you and one of me. And as much as I honestly would absolutely love to be able to sit down with each and every one of you and answer your questions about CCNA certification or automation and programmability and all these other things, I just can't. And I'm not alone in this space. Right? We have a lot of passionate instructors inside of Cisco, at our Network Academy partners, at learning partners, right? All over the place that are really passionate about helping people learn how to do technology. Unfortunately, there's not enough of us for one-on-one engagement. Also, even if you had a one-on-one instructor, somebody you could go through, imagine you're there, you're a few days before your CCNA exam, and you're doing some last-minute cramming, you're studying, and you find yourself immediately confronted with the fact that you never noticed that spanning tree was a topic on the CCNA blueprint, and you've got questions at 3 a.m. Now, generally, I don't mind if you call me at 3 a.m. to talk about spanning tree, but my wife's not really happy about that when the phone rings, right? She makes me get out of bed and go to another room. wouldn't it be great if there was somebody who didn't have a wife that was going to hit them with a pillow when you asked them questions at 3 a.m.? So that's another great use case for a tool like this. It's somebody you can ask questions when you need the answers for, to kind of bolster on top of what you might get from direct instructors or your colleagues and coworkers in that space. So the idea here is not to replace kind of that great interaction we have, right? It's really just to add on to it and provide more capabilities. So that's why I decided to build it. Now let's see it in action, right? A full-fledged demonstration of Hank's AI CCNA mentor chatbot. And so let's see how this is going to go. All right, so here we have, so I built the chatbot into WebEx, Cisco's chat platform. And we can see I've got it open here, and I've been chatting a little bit, getting him warmed up, make sure he's ready. The last thing I wanted was stage fright from my AI chatbot. But he's in place, and so I asked him initially, what do we have? I've got, hey, I'm really excited to learn about my CCNA. How can you help me? Well, I can help with some sample questions, some different ideas. I'm not just going to scroll. We're going to do some stuff live here. So let's go ahead and ask a basic question. Hey there. What domains are part of the CCNA exam? So what are the types of topics that we need to understand and know? And with luck, he'll give me a good answer. Excellent. Right. The CCNA covers several domains: network fundamentals, network access, IP connectivity, IP services. Gives me some good information. Oh, oops, lock my screen. So IP connectivity sounds interesting. What types of things do I need to know? Right? Give me the ability to explore. Now, you could look this up clearly in Google. You could go to our blueprint, or you can interact in kind of a natural language fashion, talk about there. All right, well, you have to understand routing table components, forwarding decisions, static routing, FHRP. These are some of the topics that are important in that side. And so you can kind of understand, we can dive deeper into all of these, understand what's part of it, kind of in that nice, instructive, natural language fashion. That's my favorite part about what we get out of this latest round of Gen AI and capabilities, is kind of that dynamic. I can talk to the computer like it's a friend. Now, I also know that not everybody wants to talk to a computer like it's a friend. Some people have actual real-life friends, and you don't need one on the computer. I feel great for all of you. I need my AI friends to be able to be friendly with me and help. But we have this ability to dive in. Maybe I want to understand some aspects of how it goes in. What are the differences between a switch and a router? Right? So one of the core concepts on the CCNA is the difference between components, be able to understand and dialogue through those. And so the CCNA mentor goes back and says, all right, gives you some more information to dive in. Great question. Understanding the differences is really important. So we have some of the information that's in there as it goes in. And then maybe you've been kind of doing some reading and you've seen a term, multi-layer switch, right? Well, what about a multi-layer switch? What does that mean? So we get more details that are in here. Why I'm showing this is one of the aspects that I wanted to do when we explored this capability is to kind of build beyond what you might just get out of a search engine that has some AI integration. I wanted to be able to build on the topics that are there in a conversational fashion. So the way that the chatbot's been structured is that it remembers the context, the conversation it's had with you. And you can continue to kind of dive deeper into topics that are there. You can delve in. Hey, I didn't quite understand that. Can you rephrase it? Well, it knows what it just told you, so it can make these changes as they go in a really nice fashion that is possible. And we can dive across different topics that are there. Maybe it's, we'll say, how does routing with OSPF compare to static routing? The other nice thing about artificial intelligence is it's really forgiving for typos and punctuation mistakes, right? So we go through, we get some different differences in here. So it helps you have that nice dialogue at your pace when you want it to have the information. Now, as you progress through your studies, you're going to come to a point where you think you're ready for the exam and you want to start preparing, making sure, do I understand this information that's relevant? And so we can have another type of an engagement with the CCNA mentor, the idea of kind of a back and forth Q&A. I'm getting ready for my exam. Can you check my knowledge on the topics on the blueprint? Let's start out with TCP versus UDP. And so here, you picture yourself, you're sat down, you're across from a one-on-one tutor, someone that's been helping you with this, and they're going to start posing you questions. All right, sure, let's dive into a comparison. Here are some questions that you can answer. Figure out what are the key differences between TCP and UDP. How does TCP ensure reliability in data transmission? How do TCP and UDP handle data segmentation differently? Can you provide examples or applications and services? So here are some things that we expect CCNA candidates to be able to go through and do. And I'll go in and say, okay, well, let's see how well I know these. What are the key differences between TCP and UDP in terms of connection establishment? Well, TCP is connection oriented. It makes sure conversations are heard and replied. UDP doesn't care that much about connections. All right, so give it just some sort of an answer. So the bot's able to know. It knows what questions it posed me. I provided an answer. I didn't tell it I was going to answer number one. I just started answering the information that was there. And so with luck, it'll come back and tell me how good a job I did with this information. There we go. That's a good start. You've correctly identified connection-oriented. Gives me some more details to elaborate. And it says, hey, do you want to continue exploring, or do you want to answer the next question about reliability and segmentation? Nah, let's switch to VLANs and trunking. And so again, I'm sitting there, I'm working with this like I would work with a person. And that's the engagement model that we were after here. Hey, here's some good questions about VLANs and trunking that we can dive in. I like this approach. What's really nice about this is it's not just like a question and answer piece. It lets me check some knowledge, make sure that I've got it right, and it goes in. But the exams are based on multiple choice questions. And the mentor can actually generate thousands of potential study questions that we can go after that. And so let's try one of those. Hey, I have my exam tomorrow. I'd like some sample questions to practice how well I'll do during the certification. Can you help me? Oh, now it's back to the free text. It didn't pick up on that piece. No, I need multiple choice questions. I'm in a demo. Give me what I asked for. Here they go. All right, so here's a multiple choice question for me. Which of the following statements about a VLAN is true? VLANs are used to segment a network into different broadcasts, can only be configured on layer 3, reduce the number of broadcast domains. D, VLANs are limited to a single physical switch and cannot span. Please select the correct answer. So I can look at these, kind of figure out which one I think is right. I actually think it might be 2 answers on this one. Tricky little CCNA mentor on that side. I think it might be A and C. Who thinks that's right? Yeah, I got both of those. All right. I think both A and C are correct answers. Oh, it thinks only A. C, reduce the number of broadcast domains. It's false. It actually increases the number of broadcast domains because each VLAN creates its own broadcast domain. Look at that. It was actually right. I'm a CCIE and I got a question wrong. Nobody tell my boss. I'm going to pretend like I totally did that on purpose, where I actually just kind of very quickly jumped to the end answer on that. But look at that. It was able to kind of give me that context and jump in. That was great. Let's see. If you'd like, I can provide more multiple questions. Yeah. Let's do some more. All right, here's another one. What's the default VLAN for Cisco switches? My confidence has been shot for the entire rest of this piece here. Who thinks they know the answer to this one? What do we think? A. I think A is what I've heard. So let's see. A. Great. That is indeed the correct answer, and it's given me another one as I can jump right in. And I could do this forever. Eventually, a real person might run out of ideas for questions. The joy of the artificial intelligence is it can just keep going and generating some nice questions to help me get prepared. I can jump from topic to topic as it goes in and have into that. Now, there's another aspect of studying networking and also going for your CCNA, hands-on practice. How many people are CCNA certified? Got a couple out there, great. When you take your exam, it depends on when you took your exam, but when you take your exam today, you will be presented with a handful of what we refer to as lab-lit questions. You're actually put on the console for devices and asked to configure some things. And so we want hands-on practice. Hey there, oops. How can I get hands-on practice? So the CCNA mentor should come back and give me a few options. There are some great solutions. Cisco Packet Tracer, so it points me at that tool. Points me at Cisco Modeling Labs, formerly known as Viral, right? It even has some history involved in there. It knows that it's there. It can give me more advanced simulations. And then, ooh, I like this one, Hosted CML Lab. I can set up a hosted Cisco Modeling Labs provided by Cisco U. That's super handy, where you can practice networking concepts in a cloud-based environment, or if you've got physical. Hey, number 3 sounds really good. I'm interested in that. Let's say hosted labs sound awesome. Can you set one up? Absolutely. I'll set up a lab. Please give me a minute. Took less than a minute. And it pops up and gives me the access information to a Cisco Modeling Labs instance hosted by our lab platform for Cisco U. Got a nice link, the credentials. Let's kind of dive into that. So I'll say access the CML UI. Here it comes. Go admin. Oops, 1, 2, 3, 4. Log in. I have a nice Cisco Modeling Labs server provided by Cisco U for me, forced on the back end where I can do some practice, but it's empty at this point, right? I'm a CCNA, I'm getting started, but I'd like a little bit of guidance on what I might need to know. So I'll switch back and say, thanks. I'd like to practice OSPF configuration with some routers. Can you give me an example scenario? All right? So I know what I want to practice. I've got a hands-on environment. Can you help me out with an example scenario? CCNA mentor comes back and says, sure, I've got set up for you. Here's a scenario. We've got a couple of routers. We've got another router in place. Your requirements, please configure OSPF on all routers to exchange information. Ensure that R1 and R2 can communicate with R3 through OSPF. Verify the routers have learned OSPF in place. And then if I go down, that one went through. So that gives me an example. I could start to build this out. All right, how about an example, for VLAN configuration with some switches and hosts. So I can sit here and continue to ask for examples that I can now go build and represent inside there. So I get another example that goes in, switch 1, switch 2. I've got some VLAN information, VLAN 10 and 20. Access ports are done. Oop, and look, it just popped up. A CML topology that can be used to study this scenario has been imported into your hosted lab environment. Well, that's even better. If I switch back, sure enough, look at that. My VLAN configuration with switches has just shown up on that hosted lab that was given me. If I go ahead and jump in, I can look at it. I could start that lab up. And then that entire scenario concept, the instructions, it's been injected into the actual guide for the scenario. So now I can read through and have that all captured along with what I'm after and work through that information. So now I've integrated in the ability to answer my questions about the CCNA, study, get hands-on practice tied in with hosted services here from Learning and Certification in Cisco U, and have all of this information available for me. Pretty interesting, right? Useful for our studying capabilities. Now, when I demonstrated this and kind of put it together, I sent it off to some of the leadership here in Learning and Certification. I said, tell me what you think, what goes in. And as is pretty typical when you talk to your leadership, they said, great, but could it do this? And the could it do this for me that came from our VP, Par, here from Learning and Certifications, is that's fantastic, Hank, it's awesome, but you know, not everybody in the world speaks English, right? Can it communicate in other languages? And I said, I don't know, give me a minute, let me try out. Now, unfortunately, Hank only speaks one language. That would be English. I'm American. We're really lazy on the foreign language thing. You guys do it far much better than we do. And so I'm gonna pretend a little bit and say, okay, we'll go from English into French. So I'll throw a question in. Can you explain the difference between TCP and UDP? And then I'll cheat a little bit and grab this one and say, okay, we'll grab that and say, all right, let's see if I get a good answer back. Now, I've been talking in English, so I've trained it. It thinks I know English. Let's see if it'll switch over to French without me resetting it. It did. So I get this nice answer kind of out there. Now, I don't speak French. Some of you might. I'll cheat a little bit and just take part of this and switch back and see how well it did. So I'll put that in. Look at that. Sure. Here's an explanation of the differences that are in place. So now the bot, in addition to that, now we've enabled kind of bidirectional communication with people around the world, right? I've set it up and tested French, Spanish, Dutch, Arabic, right? German, but there's all sorts of languages that are just natively supported through translation capabilities that's offered and enabled by all these AI capabilities. Really nice feature set to be able to have in that space. Nice? All right, excellent, I love it. All right, let's go back to the slides for a minute, and we will kind of pick up a little bit as I've got about 10 minutes left. All right, so that was our demonstration. So what did it take? How did I approach building the CCNA Mentor Bot? The first thing I'm going to start off with, and I'll be completely honest about this, is I am nowhere near what I would call an AI expert or an AI developer expert. I barely like to qualify as an expert in anything, and certainly not this one. So the way I approach this is the way I approach most things. It's just a little bit at a time, look at what other people are doing, take some classes, take some labs, and just kind of build and break things as it went. I also am a big fan of Python. So the way I made our CCNA Mentor here is I started with Python. That's the language I knew. And what's nice is there's a lot of capabilities that you can do to tie back in for all the other aspects that are involved here that works well with Python. Now, I needed to run it in a few different locations. I wanted to run it on my laptop. I needed to be able to run it in different development environments. I needed to be able to run it in a production-ish environment so I could do demonstrations here and have other people look at it. And so I Dockerized it. I containerized everything up. Needed an LLM on the back end, right? Large language model. So we're using OpenAI. Specifically, Cisco has its own instance of OpenAI called Bridge IT that has security and intellectual property and wrappers around it, so it's safe for us to use with company data. So that's the one that we leverage there. Obviously, I leverage my knowledge about WebEx and WebEx bots to be able to have a nice, easy dynamic to pull those together. Cisco Modeling Labs gave me the ability to dynamically generate on the fly. So the AI is actually creating those network scenarios based on the requests that go in. If I ask a question 3 times, I might get 3 slightly different answers. And so I use Cisco Modeling Labs plus the AI to dynamically build these CML topologies that can then be loaded up and launched. And then one of the latest features we added was the integration of the Cisco U Lab platform. So as you're going through, if CML or if the bot suggests, hey, CML is a great way to get hands-on practice, you don't want to have to then stop and go spin up a CML-free instance and kind of go through all that process. You want to work right away. And so I said, okay, can we tie that in with our labs platform to automatically, like on demand, give you that piece? And our APIs and our programmatic capabilities that were in there offered me that ability. And so all of these kind of broke down into a few different pieces. I don't have enough time in this session to go through kind of a full technical explanation, and frankly, I wouldn't want to. I'm hoping to do a kind of a rebuild of this use case now that I've learned a little bit, clean it up into a case where it would actually be something I think other people might get value out of the architecture. But for now, these are kind of how I broke it down. The things at the top are just kind of rudimentary web-based applications that need to be done. Nginx, and Gunicorn. But the actual components for the bot, right? WebEx Bot is a framework that I actually put together many years ago when I first started in automation to make it really easy to build WebEx bots and chatbots. So I started with that as a foundation. And then I had to build some libraries and interactions that I refer to as the AI mentor, right? You can talk to OpenAI in 1,000, 10,000 different ways. What makes one OpenAI interaction or any AI, whether it's Gemini or Llama or any of these, is kind of how they're set up, the persona that's given to that AI bot. And so I built up an ability to say, okay, this is what CCNA Mentor knows. This is how they react to people. This is kind of the interaction, right? You're going to ask questions, and the goal is not just to give people the answer, it's to pull it out, right? We want to teach people something. We don't want to just kind of like shout it at them. And so I told it, hey, use a Socratic method for teaching, right? Don't just answer, if someone asks you a question, don't just answer it, give them a question that then will kind of tease information out. So all that's built into kind of this mentor persona. And then every now and then the mentor would spit out a network scenario. I needed to be able to detect and process that scenario and turn it into a CML topology. So those were components that had to be built and tied back into the LLM. Because each one of those scenarios that are generated by the AI, they don't look the same. I was doing a kind of a practice run through earlier today and asked for something similar, and the CCNA mentor got really kind of fancy and started throwing like ASCII art at me, right? Rather than describing the scenario and how things were connected, it was like a bunch of ASCII art. And I'm like, whoa, that was unexpected. Unfortunately, my topology builder didn't know what to do with those, and so I had to skip past them. But you never know what you're going to get with AI, and so I had to be able to react to those. And then lastly was the lab management integration back to Cisco U to pull these things together. So lots of kind of capabilities to come in on that side. All right, I'm down to 5 minutes. I think I've done pretty well. Let's kind of start to pull things together. So in review, what can the CCNA mentor do today? It can do a lot of things for students that are studying for their CCNA. It has the ability to answer questions about the exam and the blueprint. Hey, what do I need to know? You probably, maybe you would, but you might not believe me when I say I talk to a lot of students that are studying for the CCNA or the CCNP or an expert exam, and I ask them, hey, have you looked at the blueprint? Do you know what the topics are on the exam? And they may have been studying for 6 months, and they're like, no, I'm just studying. And I'm like, wow, you really want to know what you're supposed to understand before you take an exam. It's like the first thing that's in there. And so I said, okay, let's make sure we can help people understand that. It can explain the topics in this conversational approach, like you're sitting down with another person. It'll ask you questions. It'll check your answer. If your answer's not quite right, it'll tweak it and give you like feedback and say, we want to adjust a little bit. So it's a nice dynamic for teaching. We have the ability to offer network configuration scenarios and then practice environments inside of Cisco modeling labs on top of Cisco U. So a nice kind of initial prototype set of features from an MVP. But there's so many more potential things that we're considering doing in this space, bringing artificial intelligence into the learning and technical learning area. And here are some of the things we're considering. Right? I would love to see CCNA Mentor, right? He's got his nice CCNA book here. He's hoping to get it signed by Wendell Odom at some point. I'm trying to line that up. But what if he knew and could tie back into your profile on the other learning activities that you're doing? And maybe because it's a Cisco and it's a learning tool, it understands that you recently went through and took a quiz, a practice exam for CCNA on Cisco U, and there were some topics that you didn't quite get right, and it could help you study those areas. Or maybe you're a NetAcad student, and we can tie into your NetAcad profile and help you kind of study in that direction. That would make it more personalized, like a real tutor, someone that actually is tied up with you and understands your personal history. There's a certain level of memory that it's set up with right now. If you talk for day after day after day, it doesn't forget what you've recently talked about, but the memory for any AI function is only so big, and the bigger it goes, the more it costs. And I'm not going to go into the cost of building and generating. It's irrelevant for today's conversation. But as the memory gets bigger, the cost of every question goes up. And so I want to figure out how to have a deeper memory, but that doesn't generate quite the cost that would be required for it to remember everything it ever talked to you about. So we're exploring options in that space. All of my suggested labs are based on CML now. Packet Tracer has a whole library of capabilities that I'm looking at. And then I also like this idea, right? If you actually sign up and you have an instructor at college, or if you're getting instruction from a mentor through a learning partner, they might check in with you occasionally. Hey, I haven't heard from you in a couple of days. How are things going? Did you study VLANs like you said you were going to? Hey, let's have a little quiz about this, right? A little unsolicited to help students not fall off the bandwagon after some big event or a weekend that went in. Keep the momentum going on that side. So again, these are some of the things we're considering what we might be able to add into this space. All right, are there any questions? Okay, we'll go here first and then back to you. Yeah. Say that again? I got you. So the question is this only available for CCNA or the other certifications? The prototype that I built is CCNA only, but it's just because I wanted a prototype that I could scope appropriately. The basic structure would work for any of the certifications, and I actually was talking with some of our leads about even up to CCIE and collaboration in other areas. So nothing would prevent it getting there, but today I just built the prototype for CCNA only. Question?
Have any idea of a roadmap when this
Yeah. So any idea of a roadmap when it may launch and be available? Short answer is no. This was completely a skunkworks prototype project that I got permission to experiment with. The next phase from now is to go back and talk with our product managers to see if this is something that makes sense. Sessions like this is an opportunity to kind of gauge interest on that, which gives me a nice transition into this. So a couple of questions from me back to you. Does this seem like something that would be useful, not just for CCNA, but for kind of the entire learning spectrum? I'm seeing some nods. I thought so. That one seemed like a pretty easy answer. Potentially a harder question. If this was something that we offered, is this something that you think that people would be willing to pay for a capability like this? Or is this something that you're like, oh, no, it's great, but yeah, I'm not going to pay for it, right? Let's hands. Who thinks that people would be willing to pay for a service like this? All right, I'm hoping my product managers are watching. All right, excellent. That's what we need to know. I'm not going to go deep into like how it goes in or the ethics and the cost and the power consumption, but all of these things do have those resources that have to figure out. So that's the other side for the delivery is we have to figure out how do we do this in a way that's sustainable, right? It's not like we want to make millions of dollars off of CCNA Mentor, but we have to do it in a way that we can make sure that it will be there long term before we go forward. And questions like that are a big part of it. All right, I've probably got time for one more question. Anybody? Yeah.
Like potential hallucination.
It's good. How do I deal with potential hallucination situations? I have a talk tomorrow on AI and network engineering, more in general, not just this, where I go into it deeper as well. But the short answer is hallucinations right now are a key part of what you just have to deal with artificial intelligence. There are a lot of strategies for dealing with them. The way that I've dealt with it here is I know they're there, and some of the use cases I've done, I remind people, hey, check my work, right? Make sure, don't just copy and paste this into the network. One of the things we're looking at in the future is how we can actually have a structured model for LLM that is kind of less hallucinations come out. Not none, but a lot of the hallucinations come because the way that the models were trained were from public data. And here's an honest example that I had. I was recently preparing for a video, a demo, asking a question, and I asked it 7 times. 6 of those times, I got the exact right answer as expected. The 7th time, I got a wrong answer that sounded good, right? It was a nice hallucination. And I was talking with some of my coworkers about the hallucination, and we think we figured out where that one particularly came from. The question was about what was the, how to build a filter for OSPF traffic, right? What port, what protocol, all those things. The correct answer is IP protocol 89, right? The incorrect answer I got was UDP port 89. Sounds great. Totally wrong answer. Our guess is why it's wrong is some of the data that was trained, these models were trained on, were unfortunately brain dumps, sample questions, sample tests that are there. And I guarantee on some CCNA exam, we had an incorrect distractor answer on a question that said the OSPF was UDP port 89. So it was connected with that information, and the LLM spit it out. And so we're looking at ways that we can actually just have good information in to make hallucinations less likely to come through. All right, with that, I want to thank you all for joining me today in this session. If you have any more questions or anything, you can always reach out to me. My contact information is generally easy to find, but I'm hapresto@cisco.com. We have a lot of really interesting content and sessions here at Cisco Live in the Cisco U Theater. Please stick around, take advantage of the time. Talk with other experts, talk with other community members that are around. Let us know what you're after. Particularly this AI topic is growing a lot. slight shameless self-promotion. As I mentioned, tomorrow afternoon, I'm back in the theater talking more broadly about artificial intelligence and its impact on network engineers and the role. I don't have all the answers. I'll cheat on that side and let you know. But I'm trying to approach this the same way we approach network automation, right? Together with the community, experimenting, kind of giving some information. So if you're interested, join me tomorrow back here in the theater for that. But for now, take care and enjoy the rest of Cisco Live.
Am I good? Am I good to go? All right, so welcome. Thank you so much for coming to hear me talk. I always wonder about this. It's like, what will I say to people and will it make sense? So I appreciate you giving me some of your really valuable time. This is Ethernet for AI networking. Now, as you've seen, AI is everywhere. In fact, I had a look at, and all of the sessions here have AI in their names. So I'm going to try and talk a little bit about the networking evolution for AI, really focusing on back-end training clusters and that technology. Right, there's a whole lot of stuff here about an introduction. I'm not going to read it all. I've been at Cisco since 2005. I helped build the Catalyst 3850, and I do a bunch of other stuff. If you really want to know what happens, go read my Substack. That's got a whole bunch of stuff on it. All right, so I'm going to go through what's the problem, where are we, and what's next. $180 billion in infrastructure. Like, just think that through, how much money that is. The accelerator market grew 130%. Right, these numbers are just stunning. They reckon that the DC and NIC markets will double. The hyperscalers are actually doing both renewable and nuclear power. So Microsoft in the States has signed a 20-year contract to reopen 3 Mile Island nuclear power plant because they need all the power. Multiple hyperscalers are investing in small modular reactors. They can't get the power, either they can't buy it or they can't get it to their facilities. So the thing about, you're going to start building hyperscale data centers with nuclear reactors on site. This is wild. So Blackstone estimates 40% increase in America's electricity use. Electricity use used to be going down before Gen AI. It is almost everywhere else. So EVs will come up, but this is enormous. This is the money is revolutionizing what's happening. By the way, so I'd encourage you to go and read some of these links later on because there's a lot more information. I can only scratch the surface, but whatever you find interesting, go follow it up. But this is the problem we have to solve. Okay, so AI/ML. So why does the network matter? So what's interesting is the AI/ML is actually looks like a OT process, process control, which is work, communicate, work, communicate. If anyone's done factory automation, you'll be familiar with this. So the process stuff is you get a bunch of GPUs and you run some code on them. So what happens initially is a bunch of initial data is retrieved to the GPUs and you tell them go. They'll go off and work for a while and then they have to exchange state. Everyone has to have the same information about everything. So this is an all-to-all communication. Now, as you all know, the GPUs are god-awful expensive, and so the job of the network is to try and keep them busy. So for a very small period of time, maybe a couple of percent of the network is busy, but it has to be 100% busy. So you've got all these guys over here, they've got a whole lot of data, and so imagine if we all had to exchange information about what our calendar was. How long would that take us to do? So the trick is you can't proceed until everyone is stable. So it's a barrier operation. So we have to get everyone agreed before you can go and do the next piece of work. So normal Ethernet load balancing doesn't give you a good answer because flows are in the wrong place. These are very big transfers. So we need the network to be 100% busy for a very short period of time and not to drop any packets. If you drop packets, then you have to restart. Your GPUs are doing less things. If it's really bad, if you have a link failure, you may have to actually roll the state back to previous state. These runs can take up to 2 months or 3 months. If you lose an hour of GPU time, that's a lot of money. So the real thing is you've got to have these things synchronized, and the problem is it's the last person. If, for instance, 2 people drop a packet, everyone else has to wait for them until that packet gets retransmitted. Right? This is really different to how most of the internet works, because these are special purpose homogeneous networks. I mean, imagine you set it up and it runs for 3 months, right? And then you get the model out. So the way it has to run is entirely different. So one of the things the hyperscalers talk about is they really care about resiliency, because a link drop is a huge deal for them. So they actually wanted to have no problems for 3 months. That's their ideal world. It's called job completion time. So if you guys remember TFTP, it's very simple, it's a packet at a time. FTP is a window. So we're doing very large transmissions, and we're really trying to say from when we started communicating to when we finish, that's what matters. Because if that time is shorter, the GPUs run for longer. All right, so Cisco's been looking at this for quite a long time. If you go over into World Solutions, you'll see a chip over there called Silicon One. I think it's the 51 terabit chip. It's like this big, 1,000 pins. So this is based on a presentation from 2022 by a friend of mine called Rakesh Chopra. He's actually done very well. He's now an SVP and a Cisco fellow. And he's looking at job completion time. So traditional network load balancing, which you guys all know this, right? What you end up is a flow goes one direction. And we don't know how big the flows are, so you're inherently inefficient. In this case, you have a small number of very long-lived, very high bandwidth flows. So we can't just pin them to links because it's not going to work. So what we would suggest you do is what we call a fully scheduled fabric. So if you're familiar with something like a Cisco 8000, and if your system is a modular system, you'll have some line cards and some fabric cards. What we run inside that is a scheduled fabric. So we run a VOQ system, and we know where all the traffic is. We're going to balance all that traffic out. So we can extend that and run basically a cluster with the same structure, which we call a fully scheduled fabric. Now that gets you, according to our simulations, 2x better job completion time, which means the network is taking half the time, which means the GPUs run for longer, because our job fundamentally is to keep them running. So this is a link back from 2022. We've been working this for a while. Go take the slides and the videos. Rakesh is an awesome speaker, and he'll explain it better than I do, because we're just doing a quick go across the surface. So the key thing is you're doing nothing almost all the time, but then you have to be really efficient when you actually get to work. All right, so it's really the question of how do I get the money? So the only reason we exist is to keep the GPUs busy, nothing else. And any what you spend on the network is what you didn't spend on the GPUs. So throughput under full load. Right, this is something we don't normally worry about. Anyone done Token Ring in the old days? Cool. So Token Ring was excellent under load because it didn't degrade. Ethernet traditionally with CCNA got worse. So the goal is 100% utilization under full load. Reliability and resiliency. If you look at the number of devices in here, people are going to be building clusters of upwards of 100,000 GPUs. Having the network go out is really not a choice, right? This is running a long run of something which might be running for a month or two. And power, right? So we all know power is a problem. We talked about the nuclear power stuff. So did anyone look at any presentations from the recent OCP World Forum? Okay, so there's a effort that Microsoft and Meta are doing together called Mount Diablo. They're going to run 400 volt DC into the rack. Why? They want to build a 130 kilowatt rack. Okay, cooling that is going to be a challenge. So again, it's not that the network is a significant amount of power, it's whatever power we use in the network can't be used elsewhere. So where are we? All right, so terminology-wise, the back-end network is data between GPUs. The front-end network is basically how you talk to the rest of the world. So scale out in the back-end network is how you go between racks or blocks of racks or data centers. Scale up is what happens inside the rack, and maybe within 2 racks. So the classic scale-up technology today is NVLink. and it's going to run within a rack. I think there's one idea to run it between 2 racks. So this is it's very high bandwidth. It's 10x the bandwidth of the scale out, and probably more than 10x number of connections. And so scale up and scale out are very different. Scale up is the majority of the links. So in both cases, almost all the links will be copper. They're going to run copper wherever they can, fundamentally because it's more reliable and less power. All right, so let's look at some technologies. I can't claim to have drawn this slide. I borrowed it from someone else. All right, so we have the network sitting here, right? So this is the scale up. So this is inside a rack. So inside a rack, you're basically connecting all those devices together at very high bandwidth. The technologies you tend to see is NVLink from NVIDIA. Infinity Fabric is AMD. There's a group called UA Link, Ultra Accelerated Link. They're trying to come up with an Ethernet-based alternative. Because what we know over time is that Ethernet technologies have been good enough with a big enough supply base that they've become more efficient to run. So the goal is to move for Ethernet everywhere. So inside the scale-up network, this will end up being an Ethernet-based network, we think. It could be partly CXL as well. But the one I'm actually most interested in is the scale-out network. So for scale-out today, InfiniBand is considered the best. How many people here actually know about InfiniBand? Or a couple. So while it's so they can correct me when I get this wrong. So InfiniBand as a technology, I think 5 years ago you would say was declining, probably in the fiber channel. But it just happens to deliver the exact type of semantics you need for this. It gets you reliability, and it gets you predictability, it gets you low jitter. But it has some problems I'll get into. We really want to go to Ethernet, and there's a group called Ultra Ethernet, which is trying to basically define the set of characteristics we need to add to Ethernet to be a functional replacement for InfiniBand. Now, what you tend to see over time is as we bring up technology A to replace technology B, we want technology A to do everything technology B did, plus more. Then over time, we figure out what we don't need, and it drops off. I mean, I've worked on ATM, I've worked on a bunch of this stuff, I worked on Sonnet, and originally we thought you can't carry voice or CBR traffic across Ethernet, and the answer is you can. We didn't need all the stuff Sonnet did, we just needed a subset of it. So we have to figure out what the right subset is to build that we can be a credible alternative to InfiniBand. All right, so InfiniBand versus Ethernet. So this is so this is NVIDIA's point of view. The network is 20% of the cluster cost. I don't actually know this, but I sort of suspect it's actually less than that. And what they claim is it's better performance at scale. So they're saying it's free, even though it's more expensive. Now, given that they dominate the market, they probably would say this. But even NVIDIA, they have an Ethernet solution as well. It's called Spectrum, because it comes from Mellanox. So this is what NVIDIA would like you to think. And this is from an article a while ago. But here's the problem. We all know that the web scalers are very rational. They always want multiple people to supply. It's not really an interoperability thing, because they wouldn't mix stuff inside a cluster, but they want to be able to build different clusters with the same functionality from different vendors. So there's a friend of mine at one of the analysts. So we're here today. He's saying he believes it's going to be all Ethernet. And the reason it will be all Ethernet is because it will be good enough from enough suppliers that it will make more sense. It will also end up being simpler, because InfiniBand is not easy to deploy as far as I understand. And we really, in fact, want to have less functionality in the network, right? The network just wants to make sure it does that one good thing. When it has to do work, it has to deliver all the packets to all the people. Apart from that, it shouldn't do anything else. Scale. They're looking to build clusters upwards of 300,000 devices. The cluster is going to span multiple DCs within an area. And InfiniBand is not going to scale to that. I'm watching up here for my InfiniBand people to see if they tell me I'm wrong yet. Supplier diversity. Ethernet is everywhere, and NVIDIA Mellanox dominates the InfiniBand market. Now, we all know if you're the only supplier for something, that gives you the luxury of pricing up. The web scalers don't like paying extra money. They need to have alternative suppliers. Now, it doesn't mean they'll go all Ethernet, but they need to have an alternative they can build the equivalent functionality in. Cost of operations. Over time, Ethernet has become the cheapest thing to do just enough. And the trick with a lot of these things is to not do anything extra. So we know having less technologies is better. If you can eliminate all the other versions, then your cost of operations is easier to run. There's a group here called Semi-Analysis. They're actually they're a pretty startup analyst company. They used to post on Substack. I actually paid a subscription for myself because they made me smarter. They write really well. So I'd encourage you to go take a look at their writing because they made me smarter on this stuff. And no, they're not giving me any money. So you guys all know RFC 1925, yes? The fundamental truths of networking. So the thing about the hyperscalers is they all do it differently and they all think they're right. So this is Google's network. Google's a little interesting because they do most of their work on their own TPU chips they've designed. But the way they structure the network is actually they have built their own proprietary optical switches sitting up here. So it's a software-defined structure. If you get something fails, they can basically use software to change the topology of the network. Then if you have different workloads, they can change the network sizes. So they end up having a much flatter network with a much bigger fan out. Meta runs a rail-only design. So what you end up doing is each of these guys at the minute, they're all doing it differently. Now, if they want us to move really fast, they're going to have to simplify because we can't build all the things all the time. If we try and do everything, we'll fail. So what's next? All right, so who's doing what? So I chair an organization called Ethernet Alliance. We're a vendor alliance, we promote Ethernet. We have a couple of roles. Ethernet's fundamental value proposition is you plug it in and it works. Now, as you can imagine, there's some interesting stuff behind that. So we try and make sure it does work. So when products are about to come out the door, we'll run closed-door plug fests, we'll get the vendors together, and we'll get them to beat it out and make sure it does work. All right, because this is not magic. So once that happens, we'll go to a show like OFC or ECOC and we'll show it working. Because when you as a customer want to deploy it, you need to see it working on someone else. The idea is you're not going to ever buy something based purely on the data sheet. You need to see it actually working somewhere. Then we talk about it. So in this particular case, what we're trying to do is herd the industry in the right direction. You guys have all heard about the comment of herding cats being hard. Right, so there's actually a video on YouTube, which is the cat herding video. It was an advert from a systems integrating company a number of years ago, and it shows people herding cats across the prairie. EA's job, we're trying to herd people to go the right direction. What you tend to find is everyone thinks they have the right answer, and they want to locate that answer in their place of it. But unless we get the industry working together, we will never be able to deliver what's required. So, I also do work in 802.3 working group, which defines Ethernet. I actually work in the slow speed side of Ethernet. I'm actually working on projects that are running at 10 megabit and 100 megabit at the minute. And if you want to hear about single pair Ethernet, we can talk about that later. On the high speed side, 802.3 DJ is defining 200 gigabits per lane. So this will be single lane 200 gig port. It will be a 4-lane 800 gig. Now, that project's underway, and they're doing a lot of technical work, because this is towards rocket science. Anyway, my friend John D'Ambrosio, who chairs that project, was at OFC last year, I think, and he had someone from a hyperscaler come up to him and say, look, 200 gig per lane is done, when are you going to start 400? It's like, guys, we're still trying to figure this out. So the expectation of the hyperscalers is we then deliver the value proposition and reliability, and we're going to do it all tomorrow. This only works if we decide to do the right things. So we're starting to look at what 400 gig per lane might look like. So the Ultra Ethernet Consortia, this is the vendor group. There's always lots of vendor alliances around the industry. The goal here is to basically define what's required to be added to Ethernet to give you functionally equivalent of what's required for an AI network. Notice I didn't say functionally equivalent to InfiniBand, because we need to do just the stuff that's required and nothing else. Now, of course, people get excited. They want to do everything. So people start off with, we're going to do all this stuff. But eventually, we have to chop it down. If we don't, we will fail. Adjacent, there's a group called the Ultra Accelerator Link. So again, in scale-up, the dominant technology is NVLink. NVLink is NVIDIA's. If I want to start having multiple suppliers for these things, I need an alternative. So this is the let's use Ethernet instead of NVLink. So again, it's the same thing. They've got to figure out the minimum to do. There's lots of things we could do, and if we do them all, we won't succeed. Rule 12. You're not done until there's nothing left to take out. So you can imagine this in your documents. Like write a document or an email, and it's the same in slides. You've got to get rid of everything you don't need. So Ethernet really today, it's not CCMACD anymore. It's mostly a frame format. It's a way of doing things more than anything else. So we need to figure out just what has to go in, because that's the only way we can deliver in a time and a scale and reliability that the industry is expecting us to. So let's talk about the Ultra Ethernet Consortia. So this is a company, organization Cisco is deeply involved in. A friend of mine chairs it, a gentleman's called Dmytro over at AMD. And so they have a pretty ambitious schedule, right? They're going to look at everything. Now, I think probably they're going to end up solving a lot less of these problems, because we're going to figure out that the networking industry isn't the right people to solve some of these. And the web scalers do things at strange rate, like Google protobufs. They write their own protocols, they do their own compilers. So some of this stuff is going to end up being theirs, not ours, I think. Some of this stuff will go to other organizations. But from the Ethernet side of the house, we need to figure out what to add, and from some points of view, how you should consume the network. So one of the things they're working on is link level reliability. They're actually going to do retransmissions at a link layer. Now, I personally think this is probably the wrong answer, because I think this is going to be a host problem. They're also looking at spraying traffic across the network and then reordering it as it leaves the network. I think the spraying is clearly the switches problem, but I think the reorder is probably the next problem. But we all know the case of, look, I have a hammer, every problem is a nail. So it's like, if I build switches, I want to make the switches the answer for everything. But I think that runs into the problem. So imagine if your favorite soccer team recruited 15 Cristiano Ronaldos, right? Their soccer team would stink. What we need to do is actually play position and do the right things in the right places. So in this case, I think, personally, the end device is the place to do reordering, because it's going to be multiply connected. And it's got to store the data anyway. So again, it's how do we make sure we do the right set of things? I'm going on time. All right, so here's the net. I'll even have time for questions. So Ethernet will become a dominant technology for scale out. I don't know quite when, but it will. What does that solution look like? We're still trying to figure it out. We're trying to get together the web scalers, who normally don't want to talk to us, the system vendors, the Ethernet vendors, the PHY vendors, to go, we don't have the time to muck around. Give us exactly what we need to build. And the answer is they don't really know, they don't agree yet. But if, we all know this, if someone comes to you and everyone comes to you with a different ask, right, you can't succeed. We have to do just enough. So it has to become viable. So the cost of the network is actually trivial compared to the cost of the cluster, both in money and power. So strictly speaking, they can spend whatever they like, but they don't want to. They want to have it most efficient. So again, the goal is just enough and no more. As I said, the network's a small part of the system, but they want to resolve cost everywhere. Right? These guys are hyper efficient, so they're going to go and say they're going to optimize cooling costs, the whole swag and dice. So if we have a more efficient network, that's going to be worth a lot. But they've got to be able to get it from multiple suppliers, because they don't want to have a supply chain risk. Also, if you're the only supplier, then you tend to lean on margins. So they want to be able to build effective clusters from lots of different suppliers at low cost and operate them reliably. Ethernet's done that really well over time, so they're expecting us to bring that value proposition into this area. I actually have time spare, so I can take questions, which is way cool. Would anyone like to, got any questions on this topic? If not, then I'm actually done early, which surprised me. Guys, thank you so much. My day job is actually being inside Cisco as a reporting up into the people who build a lot of hardware, but what I get to do is a lot of communication. And for me, this is one of the most valuable parts of what I do, because I provide context to people. So this is like one of the best days of my year, except for 15 minutes before when I checked my slides and there was a mistake in them. But again, thank you so much. Come up and talk to me afterwards. That went lots faster than expected.
Thank you all for coming. We'll get started in just a couple of minutes. Once it ticks over to 2:30, you'll start bang on time. But thanks for coming. There's still a couple of seats at the front if anyone is looking. I think there's one seat at the front if you... All right, I might make a start. Thank you all very much for coming to this session today. My name's Chris Gascoigne. I'm a Principal Solutions Engineer here at Cisco. I am from our APJC region. I'm based in Melbourne, Australia. So that means if I muck anything up, I get to use the excuse that it was jet lag that caused that. So this session, we're going to talk about AI infrastructure. And it's a 30-minute session, so we can't go too deep. And I will apologize if I do go a little bit fast. There's a lot to cram into 30 minutes. But my goal of this session is to really help you, if you don't already, get a bit of an understanding of why AI workloads are fundamentally different to the traditional workloads that we deal with in the data center, and why they place different requirements onto the infrastructure, and what requirements they are, and in what circumstances those requirements apply, because it's not universal. So let's talk about the infrastructure. And the first thing that I want to get across is that when we're talking about AI and the infrastructure to support AI workloads, it really is not a one-size-fits-all approach, just like any application. And I think this is really important to emphasize because so many AI conversations really, really quickly devolve into how many 8 GPU servers do you want to buy? And that is not the right question to be asking. The right question to be asking is, what is the type of workload that you're dealing with, the type of AI application that you're building, and use that to dictate the requirements. And I think when we see diagrams like this or pictures like this is from NVIDIA's GTC conference that they run every year, and they show slides like this with 32,000 GPUs in a data center, and the sort of amazing technology that they're building there. But it's important to sort of recognize that what they are is analogous to a Formula One car. Sure, it's great, it's the fastest thing that you can build if you have unlimited amounts of money and limited amounts of engineers, but for a lot of use cases, it's probably not what you want. And fundamentally, what we want to be able to do is think about our AI workloads and what we're doing with AI, and make the decision of what is the right infrastructure, or by analogy, what is the right vehicle for us. Do we need a racing car, or do we just need a standard sedan, or do we even need a bike? These are kind of the questions that we should be asking when we're talking about AI infrastructure, and not just default to, we're going to spend all the money we've got and give it to NVIDIA so that we can say we're doing AI. So to answer some of these questions, I always like in these kind of new areas to really go back to first principles and understand what is happening that's going to drive these AI infrastructure requirements. And so to do that, we need to think about what is fundamentally happening when we run these AI workloads. And fundamentally, all of the AI and ML workloads that we're going to be that we talk about, they're fundamentally built on ideas that are not new. The ideas of neural networks have been around for 50 plus years. And all we're doing these days is building much more complex architectures with those neural networks with much greater parameter counts. But the fundamental technology is still the same. And what we want to understand is how does these types of neural networks actually get built and actually get run in production. And in any AI workload, fundamentally what we're going to be doing is a few things. One is choosing our model architecture, and that's something that data scientists will do, and there's lots of different model architectures to choose from, and that's where a lot of the innovation really happens, is discovering new architectures that work well. But once you've got that model architecture defined, what you then do is train that model, or somebody will train that model. And fundamentally what that that training process is trying to do is, when we have a model, is define or work out what are the best weights and biases. So these are essentially numbers that exist inside the nodes of this neural network. What are the best weights and biases that enable this model architecture to produce useful results at the end? So we're essentially just going to basically use trial and error, not quite trial and error, but like trial and error, to work out what are the best values for all of those parameters to get the best results out of our model. And the way that that happens in the training phase is there's a few steps involved. So the first step is what's known as the feed-forward phase. And this is basically where we take our training data set, and more specifically, we take a sample from our training data set, we apply that to the inputs of our model, and we feed it forward through the model. So we just, the numbers flow through, we multiply them by the weights, we add on the biases, and they flow all the way through, and we get some result at the end. And this is an example of a very simple classification neural network, and we get a calculated label. What does this input, what does what do we categorize that at the end? And when we first start with this model, all these weights and biases are essentially random numbers. We just initialize them with random numbers. And so what we get out at the end is completely wrong. It's wrong in every case. But what we do is because this is the training phase, we know what the correct answer should have been. And so what we're able to do is compare, what came out of the end of that feed-forward pass, compare that to what was the expected result, and calculate the error or the difference between the expected result and what we actually got. And then what we do is what's known as backpropagation. And so this is essentially where we take that error or the difference and we propagate it backwards through the network. And essentially what we're trying to do at this step of the process is work out, well, this wrong answer that we got, of all the weights and biases in this network, which ones had the most impact on that incorrect result, on the error that we got at the end, so that we know how we can adjust the weights in this network to be slightly better the next time we put another piece of data through it. So that's what the backpropagation phase is. We're essentially propagating the error backwards through the network to understand where the sources of error actually are in that network. And then the next step is what's known as the optimizer. And so here, what we're basically doing is using the gradients that we worked out in the backpropagation phase. We're using those to just go and adjust all of those parameters, just slightly tweak them so that the next time we run a piece of data through here, we hope we're going to get a slightly better result. And so this optimizer is basically improving the weights and biases in the network so that we get better results the next time we use it. And then from a training perspective, we just do that whole process a few 100,000 times, or a few million times, or a few 100 million times, depending on the size of our data set that we're actually using to train. And that's really where the time and the cost in this training process actually comes from. Now, I just showed you a really, really simple example. Probably the most simple example that you can possibly think of in a machine learning scenario. If that model was a lot bigger, instead of having 50-odd parameters, we have 100 billion parameters, a few 100 billion parameters, and we have much larger data sets that we're using to train that model, we can't do it on a single node. We can't do that training process on a single CPU, or indeed probably on a single GPU. And so ultimately what we need to do in almost all of these scenarios is do that training process in a distributed fashion. And essentially what we're trying to do is take our training data and our untrained model and get to the state where we have a trained version of that model. But we want to do that by distributing the work across some number of nodes. I've got 3 in this example here. These could be multiple servers, these could be multiple GPUs. At this point, it doesn't actually matter. We're sort of thinking a level above that. But we're essentially trying to decide, well, what is the best way, or how do we distribute that work across these nodes so that we can come up with a single trained model at the end that incorporates all of the learning from my training data set. There's a few different ways that this can be done. There's things like model parallelism, pipeline parallelism. What I'm going to talk about here is data parallelism, because this is the sort of most common way that this happens. The other thing to be aware of is that in really large scenarios, you'll probably actually do multiple of those parallelisms in parallel at the same time to scale even further, but that gets really confusing. But for the sake of this, let's just think about data parallelism. The idea with data parallelism is that the way that we're going to distribute the work across all those different nodes is that each node is going to get a portion of the training data set, but importantly, each node is going to be working on the whole model. So we're not breaking up the model. Every single node is working on the whole model, but they're only working on a subset of the training data. And in this case here, we've got 3 nodes, so we divide the training data set into 3. And essentially what we're going to do is go through that data parallelism process, and that's going to build us the trained model. Now, we still haven't actually answered the question of, well, how does this work? How do we make sure that the model we get at the end incorporates the learning from, or the training that's going to happen in all 3 of these different nodes? So let's talk about that. I'm going to just run through this process again on just showing how it works on a GPU with one GPU to start with, and then we'll build it up to multiple GPUs. So if I've got a single GPU and I'm doing the training of a model, what I'm going to basically do is, just like we talked about before, I'm going to do the forward pass through that model with my training data. I'm going to do the back propagation pass through that model with the error and the result. And then on that same GPU, I'm going to run the optimizer to update the weights on that model and make it slightly better for the next one. Okay, that's one GPU. Back to the question, how do we do it across 3? This run, I'm going to show you the naive approach. If you didn't think about it and you just went, oh, let's try something, this is what you might try. You might have your 3 GPUs, each GPU with a subset, a third of the training data, and we might run that same process that we did on one GPU, but on 3. And what's going to happen? So we go run the forward pass, we run the back propagation phase, and then we run the optimizer on each of those GPUs. And what we end up with, as you can probably work out, is 3 different models. So we haven't actually solved the problem. We've actually made it worse. Instead of getting one model that works, we've now got 3 models that probably don't work. Not a great outcome. So what we actually do is this. So we have our 3 GPUs with the model, with each of their having a subset of the training data set. We run the forward propagation on each one, back propagation on each one. The difference here is that instead of running the optimizer now, what we actually do is a synchronization operation between all of those GPUs. And this is what's known as an all-reduce operation. And essentially what we want to do is end up with, instead of having a set of gradients on this GPU that's different to the gradients on this GPU that's different to the gradients on that GPU, what I actually want to do is end up with one set of gradients that is consistent across all of them, that is based on the gradients that they all learned. And so I essentially want to average all of the gradients across these GPUs and distribute that average across all of them so they all have the same information. And that's what this all-reduce operation does. All-reduce is typically done by in an NVIDIA scenario, by the NVIDIA Collective Communications Library, NCCL. If you start getting into this space, you'll hear NCCL a lot. That's what this is. And it does this all-reduce operation. There's a few different ways that it can do it. We won't get into that. Let's just work on the assumption that it does that operation to average those 3 sets of weights together and distribute the results to all 3 of them. Once it's done that, then they all have the same, because they all have the average, the gradient on all 3 of those GPUs is now the same. And so now, when each GPU runs the optimizer, they all end up with the same new state, because that optimizer process is deterministic. We have the same gradients on all of them. We all do the same update. We're all in sync. And then we just keep doing that process with the next batch of data, the next batch of data, the next batch of data. And that's how the training process works. But the important point here is that this synchronization step, this all-reduce step that happens between all of those GPUs, that is a communication that's happening across whatever is connecting these GPUs together. And essentially, while that communication is happening, all those GPUs are essentially stopped and waiting for that synchronization to happen before they can run the optimizer and continue with the next batch of data. So how long that synchronization step actually takes is really important. It has a really big impact on the overall time that it takes to train a model. Okay, so that's training at a really, really high level. Obviously, you train a model, you get the trained model. You then need to do something with it. Nobody trains a model for the sake of training a model. You actually have to inference it. That's the production bit of AI, is inferencing. And inferencing is really simple, because inferencing is basically what we talked about before in the training phase. The inferencing is just that, but only feed forward. That is literally all it takes to do inferencing, is you put the data in on the left-hand side here, you run it through the model right to left, and you get a prediction out at the other end. And that's inferencing, simple as that. I do want to briefly touch on a high-level concept, something called retrieval augmented generation. If you haven't heard of retrieval augmented generation yet, you probably will, because it's really, really important. Retrieval augmented generation is an approach to using large language models that aims to address some of the challenges that you might have using a large language model. And so those are things like hallucinations and asking it questions about information that didn't exist at the time it was trained, or that didn't exist in the training set of that large language model. And so retrieval augmented generation basically tries to cheat the process by essentially, instead of just asking the large language model, what is the meaning of life, and getting a 42 out, we want to give the model information that is relevant to the question at the time that we run the model. And the basic way that this works is that in retrieval augmented generation, we have a vector database, which has got a bunch of information that we want our model to know about. When we get a request from the user, we basically use a embedding model to essentially learn or understand the context of the question that's being asked. We look up in the vector database the information that's relevant to that context. The re-ranking model just sort of chooses which is the most relevant chunks of data from the vector database, and then all of that is given to the large language model. So if you ask the large language model about what's the summary of my third quarter sales reports, if you ask ChatGPT, it's not going to know that because it doesn't have access to your sales data. But if you're using a retrieval augmented generation, you would go through this process, and this step would actually give the model, here's the details of the sales results from last quarter, so that when it then answers the question, it already knows that information. There's a few important things about retrieval augmented generation. One, everything in here is inferencing. There is no training in a retrieval augmented generation architecture. All of this is just inferencing using standard models off the shelf from open source providers or even commercial providers. No training is required to make this work, which is why it's very attractive to enterprises. The second thing to know about this is, the obvious question is, how does that vector database actually get populated with the information that's going to get passed to the large language model? And basically the way that works is that we just take the documents and the like that you want this system to know about and run it through that first part of the architecture. You break it up into chunks, pass those chunks through the embedding model to understand the context, and then insert them to the vector database using the embedding vectors as the context in the vector database, so that when you go and look it up, you can find it based on the contextual information. But what's really important about that is that if all of this data is on premises and in your storage arrays and those kind of places, you probably want to be doing this part of the architecture, at a minimum, this part of the architecture, close to where the data actually lives, because you're going to be doing this a lot. You're going to be doing this ingestion process with all of your existing data, but also every time new data is created, every time data is updated, you want to go through this ingestion process. And so having this inferencing of these embedding models and the vector database actually occur on premises will make these systems work a lot better. All right, back to the infrastructure. So in terms of the infrastructure that we build to support these kind of workloads, obviously every time we're talking about AI, for the most part, GPUs are going to be involved. And if you're wondering why you're probably not, but if you are wondering why are GPUs involved in all of these AI architectures, it's because all of that process, the training process, the backpropagation, the inferencing that I've spoken about before with those models, essentially all of it breaks down into large matrix multiplication operations. And large matrix multiplication operations are really easy to parallelize. And what's great at doing parallel computation? GPUs. That's why GPUs are used almost exclusively for these AI/ML workloads. And this is not a new idea. The reason I put this slide in here is because this is an NVIDIA slide from 2007 of them, literally more than 15 years ago, talking about how GPUs are really good for deep learning, machine learning, these kind of use cases for exactly those reasons that I just talked about. And so when we look at the infrastructure, hopefully you can see that slide. When we look at the infrastructure, this is at a high level all of the components that you could have in an AI infrastructure architecture. And I'll give you a bit of a high level overview. So what you can see here is I've got 3 servers in this diagram here, just to give you an idea. In those servers, we obviously have CPUs. Those CPUs have normal NICs, just like you're used to today in all your regular servers, that connect to this network at the top. And we call that network the front-end network. Other vendors might call that different things. NVIDIA tends to call that a management network, which is a bit of a strange terminology, but that's what they use. But this is essentially where the servers will typically talk to cluster management systems. Storage might be there, although sometimes storage could also be a dedicated network, but for this, we'll just keep it there. Or the outside world, through those front-end networks. And then down here in green, what I've got is the GPUs. And so, these servers have multiple GPUs, 8 GPUs, up to 8 GPUs, potentially more GPUs in each of these servers. And those GPUs have a couple of ways that they communicate GPU to GPU for that all-reduced communication that I was talking about before. In green, you can see what I've got here is what I call the intra-host network. So this is the network inside the server that interconnects those GPUs together. And if this was an NVIDIA solution, that would be NVLink. If this was an AMD set of infrastructure, it would be Infinity Fabric. If this was an Intel Gaudi set of infrastructure, this would be Ethernet actually inside the servers. But this is an interconnect inside the server for the GPUs to communicate to each other. This is typically very high bandwidth, very high performance. NVLink today, I think, is 900 gigabytes per second, so a lot faster than what we're used to from an Ethernet perspective. Those are the GPUs. And then what you'll see down the bottom here is a set of NICs that are connected directly to those GPUs. And so this is when a GPU in this server needs to communicate to a GPU in a different server. So it's the inter-host back-end network for GPUs to communicate to each other. And this has historically been InfiniBand in most environments, but is increasingly becoming Ethernet for many organizations and many deployments these days for a variety of reasons which we can get into a little bit later. And all of this is important for predominantly training. Things like this GPU to GPU communication that is mainly relevant for training use cases. For inferencing, there's much less GPU to GPU communication. I will point out, though, that it's not none, and it really depends on the size of the model. I've put this example in here. There's sort of 3 different examples of some infrastructure. So these are 8 GPU servers with NVLink inside them. And the scenarios on the left, the scenarios are on the left, a Llama 3.1, 8 billion parameter model, a 70 billion parameter model, and a 405 billion parameter version of that same model. And you just simple maths, we know that it's got 8 billion parameters at 16 bits of precision. Let's just work with that. Could be different, but 16 bits of precision, that means that each instance of that model requires 16 gig of GPU memory. The H100 GPUs in this server have 80 gig of GPU memory per GPU. And so what that means is that in this example here, with an 8 billion parameter model, we can fit multiple copies of that single model on a single GPU. But if we go to the middle scenario, we've got 70 billion parameters. Well, now we need 140 gig of GPU memory per model just for inferencing. And so in those scenarios, we do start to care about the connectivity between GPUs, even though this is an inferencing use case. And so, we would require 2 GPUs per instance of the model that we want to run. And then on the right-hand side, this example here with 405 billion parameters, we need 810 gig of GPU memory to support that model, which cannot fit in a single server. And so we have to actually stretch that model across all of the GPUs in one server and 2 more GPUs in the next server. And so in that case, the back-end network is actually relevant even though this is an inferencing scenario. Now, obviously, there's optimizations we can make. We could do things like reduce the precision from 16 down to 8 or even lower, things like that. But at a very high level, the point here is that depending on the size of the model, even for inferencing, you need to think about the inter-GPU connectivity, both within the server and across servers. All right. The last thing I want to touch on is just a bit more on that back-end network and why we are starting to see that trend towards Ethernet start to become real for the back-end network, which is primarily going to be relevant for training unless you're running very big models that are going to extend across multiple physical servers. And I want to go through this because I think a lot of people say there's a lot of sort of conventional wisdom about what requirements exist on the network side for running AI ML infrastructure, but not a lot of people talk about the why. Why do those requirements actually exist? And I really want to explain that. So the first requirement that we all, it's kind of obvious to everyone. The first requirement for back-end AI ML networks is high bandwidth, non-blocking performance. The question that we should also understand is, well, why is that important? And partially I've explained it to you. That all reduce synchronization that happens between the GPUs, the quicker that process can happen, the faster our overall training jobs can actually run. And the reason this is important is because the amount of data that is being transferred between those GPUs is large, because it is essentially what's being transferred is all of the gradients for every single parameter in that model. So if we're training a model with 8 billion parameters, then that's 16 gig of data that every GPU has to get to every other GPU in the cluster. So it's a lot of data, and the shorter we can do that, the better. So that's why we have obviously things like 400, 800 gig Ethernet, but it's not just about how fast is my network, how high can I get the utilization on that network will dictate how quickly those transfers can actually complete. And so that's why things like dynamic load balancing, static pinning, and enhanced ECMP actually make a difference to the performance of these AI/ML workloads, because we can make sure that we actually fully utilize all of the links in our fabrics. The second requirement is lossless. And again, everyone just says this about, oh, AI networks, they have to be lossless. Okay, why? And what do you mean by lossless is the other question I think people should ask themselves. Because when we say lossless, that actually doesn't mean that the network can never drop a packet. That's not what lossless means. What lossless actually means is that the network should not routinely drop packets. And the reason that that's important is that dropping packets in an AI/ML network does slow things down. This is an example, some information that I got out of a paper that I read, which showed that a back-end network with 2% packet loss can cause a training job to take 8 times as long to complete. Now, if your job is taking 10 minutes and now it takes 80 minutes, that's just a bit annoying. If your job's supposed to take a month and it takes 8 months, that's not really sustainable. So this is really important. But the good thing is that we have mechanisms already in place to solve this. We know how to do RDMA over converged Ethernet. We know how to do priority flow control, explicit congestion notification. These are technologies that have existed in Ethernet for more than a decade now for lots of other use cases, and they can be applied here, and they're perfectly sufficient for these AI/ML workloads to essentially make the chances of packets being lost very, very low. Third thing is latency, and again, this is one of those things everyone just says, well, AI networks have to be low latency. Actually, latency is important, because obviously, the quicker we can do these transfers, the better. But what's more important than the latency being low is actually being consistent, because that actually makes the transfers between these more predictable and more deterministic, and we don't have to worry about that sort of long tail problem of one particular GPU taking significantly longer than the rest and delaying everybody else. So that's kind of where we are from a latency perspective. And then the last one, which I sort of left in here as a bit of a surprise, is people don't often think about from a requirements perspective, is operations. Because these GPUs are so expensive, you know, $30,000 plus US dollars per GPU, having a GPU sitting there idle because the network is down or underperforming because the network is slow is just not an option. And so having, you know, automation to make sure that the fabrics are deployed correctly the first time, every time, is really important, and visibility and telemetry so that we can resolve issues with those fabrics as quick as possible is really, really important, because you don't want, you know, millions or hundreds of millions or tens of millions of dollars worth of GPUs sitting there underperforming because the network is not up to scratch. Is absolutely critical. So key takeaways in the last minute here. Before you go, you know, just out there and, you know, trying to work out how many 8 GPU servers do you need to buy to do AI training, actually sit back and understand what is the type of workload, what is the type of application that you might be needing to run on this infrastructure, because the type of infrastructure you can deploy for these AI workloads is incredibly wide, and getting it wrong can be very, very costly, or, you know, very, very poor experience for your end users. Think about the strategy from an infrastructure perspective. Try to align it with what you've already got. That's going to make a lot of sense. Obviously, reduce those operational costs. And then leverage the information that we've got already. I didn't have time to go into it, but we've got things like validated designs, AI networking blueprints that you can follow that actually show you how to deploy these things in a way where you're going to get predictable results. So last thing, if you've got any questions, I've probably run out of time, come talk to me afterwards if you want, or the WebEx Teams app. Please do the surveys, and if you want to reach me, I've got my email address there. Happy to take any questions that way, or just come and see me. With that, thank you very much. Enjoy the rest of the show.
Check, check. Hello, thank you everyone for joining me today. I am Dan Stacks. I am a solutions engineer here at Cisco, and this session is architecting a private cloud for AI workloads. Today we will go through a little bit of an introduction about myself, and then we will understand AI workloads, and then go into the key components of a private cloud for AI, and then even some sample reference designs, and then how would you build your own IT operations assistant? And we only have 30 minutes here, so happy to answer questions afterwards if they come up, or also there is a WebEx space that we can use. A little bit about myself. Joined Cisco in 2018. Married with 2 kids, ages 1 and 3. They're sitting at the hotel a mile away from here right now. I don't know what they're doing, but I'm sure they're having a great time with their mom. I've been completely focused on AI since 2022. So going on about 3 years now, which seems like not that long and also forever, as it turns out. So, understanding AI workloads. I'm going to go through just a brief overview of these different components, things you should probably know. Again, in the context of infrastructure. If anyone wants to know how to train their own model from their own data, let me know. We can talk about that. But this is specifically as it relates to infrastructure. Different types of AI technology you may encounter, right? At the top, machine learning. I'm sure everyone knows a little bit about machine learning already. I'm not going to go too into the details about it. Also, natural language processing. This is your ChatGPTs, Gemini, whatever. Computer vision. Think about how a virtual manufacturing floor, how would that happen, right? And this is not an exhaustive list. This is just an overview. There's 20, 30 more of these, but typically this is where I see customers starting out with different use cases in these different realms. Training, fine-tuning, and inferencing. A quick show of hands, who's very familiar with these 3 phases of AI? Okay, a few people. So I like to tell a little bit of a songwriting analogy. I'm not much of an artist, but think of training as the composition phase of writing music, right? Crafting the melody, the lyrics. It takes the most time to get everything kind of put together. This is the same kind of thing. Figuring out AI model from scratch is basically writing a song. Fine-tuning, this is the mixing of it, right? Do I want more bass? Do I want more tempo? More or less, whatever. That's the fine-tuning process. It's still work, but less, right? Inferencing, this is actually the performance of the song itself, right? So after training's done, after fine-tuning's done, this is someone on stage strumming the guitar, playing the song, singing the song, right? So there's, again, more details into this, but this is just a high-level overview of how to interpret these different phases. And I would be amiss not to mention retrieval augmented generation. This is specifically part of the inferencing process, right? So this is a way to improve a natural language processing model that NLP, with more context and more data to make it more relevant for what you're trying to do. And the best way to describe this is it gives you the better ability to seek the specific data you want the model to have and then present it with the data in such a way that it can have a better grasp of that context, right? And here's an example. Think of a chat prompt as the user input. And a user types in, what's a dog, as an example. And the RAG piece, the retrieval augmented generation, is the search for knowledge that you can feed it. And specifically, it could be like a Wikipedia that you have internal. It could be, training documents that you have. It could be a data sheet. Any PDF, Excel, Word document, things like that, you can have through a retrieval augmented generation process. And then on the output, it enhances all of that and returns it back to the user. Okay. Model cards. So think of model cards basically as an AI data sheet, for a lack of a better term. So a model card gets published with the model on something like Hugging Face, and there are different things you want to know, again, from an infrastructure perspective, about how to size and how to interpret the model card. Parameters, everybody should have heard of a parameter by now, but it's the number of variables that a model has been trained on. And think of it, again, analogy, car parts. Like think of a car, how many parts make up a car, right? You've got every single nut, bolt, screw, you've got a radiator, transmission, whatever. Think of all the things that come together to make a car. It's the same thing. Those are the parameters in an AI model. The tokens, think of it as characters. right? And it's like bits representing data. You know, a lot of networking people at Cisco Live, it's bits and bytes equals tokens. Think of it like fuel in a car, right? Context length, how many tokens can be processed with the model, right? Again, this is fuel tank capacity, right? So you've got your car, you've got your fuel, you've got your capacity of the fuel. And let's give it a real world example of that. Here is an example model card from Meta's Llama. This is, think of it, a open source model, a foundational model, you can call it that. You can go and download this for free. Meta has spent billions of dollars developing this and has published it to anyone to go download. And in this here, we can see number of parameters, 3 different flavors, right? 8 billion, 70 billion, 405 billion. And then different context length is all 128K, right? So, and then it has the model's purpose and all that, right? So model card is akin to a data sheet. And from an infrastructure perspective, take note of parameters, context length, and number of tokens as well. Okay. What are the key components of a private cloud for AI? You may have heard of a backend network. I think most people have, I mean, it's Cisco Live. Everybody has heard of a backend network. But I want to talk a little bit more about different kinds of backend networks. So on the left here, you have a classic design where think of it like a top-of-rack switch, right? You have 2 switches per rack, you have servers cabled into them, and it's highly redundant, right? There is another piece on the right here. It is a rail optimized design. And basically what this changes is, for example, you have an 8 GPU server. Each one of those GPUs will have an associated NIC card with the GPU, and each of those NIC cards will go into a specific leaf. So in this example, we have different colors, right? Blue, light green, dark green, and each of those different colors represent GPU 0, GPU 1, 2, 3, all the way up to 7 in an 8 GPU server. And each of those associated GPU zeros will, example, go to this dark blue leaf. And so what does that do? Well, one, it breaks your redundancy. It's non-redundant at all. So if that leaf goes down, all the GPU zeros in that cluster go down. But why do you want this? Well, any guesses? Okay. It is because it lessens the number of hops in the network. So otherwise, you would have to build this in such a way that you have your leaf and then your spines. But if you do it like this, you can have all of your GPU zeros, GPU ones clustered together in a pool that can run a training job, and they only have 1 hop to the leaf and then back down to the GPU. Otherwise, they would have to go to the spines and back down the leaf. So it's 1 hop versus 3 in this example. And so a rail optimized design is an NVIDIA best practice of GPU clusters of more than 16 8 GPU servers. So think more than 16, 17 servers. Consider looking at a rail optimized network. Let's talk about some network protocols real quick. So RDMA would have to be enabled at the NIC layer, and I'll talk about that a little bit more here in a second. And then Rocky v2 would be used as transport. And you may have heard about InfiniBand. It doesn't go away in an Ethernet environment. It's just InfiniBand is encapsulated in Ethernet and then transported. So InfiniBand's still at play, and in this environment, GPUs handle the scheduling, right? So the order of sequences, the GPUs dictate all of that. And then from a QoS perspective, you have explicit congestion notification known as ECN and a priority flow control. And what that really means is, you may have heard about lossless Ethernet or how bad traffic and packet drops are for a training run. ECN, all that does is says, slow down, right? I'm getting overwhelmed. I can't process everything. Just slow down the packets, right? Priority flow control, on the other hand, is just stop. stop, let me empty all the queues, and then we'll come back and we can start reprocessing things, right? So those are the two different stages that work together. So what is actually RDMA? So in a GPU server, and think of a dense GPU server like the 885A, the entire point is to move the data as fast as possible. And the way that that happens is the GPUs have a direct connection over PCIe to the RDMA NIC, right? So this could be something like a Bluefield 3 NIC or a ConnectX NIC from NVIDIA, Mellanox. But the entire point of that is system memory and CPU are completely bypassed to get traffic from the GPUs onto the wire, right? So that's why it's so high speed and why so every GPU then has an associated NIC card with it, is because it completely bypasses the CPU and RAM of the server. And then, again, we talked about Rocky a little bit. It's I have a slide on the actual packet format of it, but here is the process to get from the GPU to on the wire. And Rocky V2, again, as I said, it's an InfiniBand payload within an Ethernet frame. And InfiniBand does not go away. It's how the GPUs, at least the NVIDIA GPUs, like how they actually communicate with each other. And it can be routed. Rocky V1 cannot be routed. Rocky V2 is a routed protocol, uses UDP port 4791. And then actually the port header here carries the source GPU traffic. So with that, what kind of switches should we be looking at for this back-end kind of network? So we have a few different lines here. The gray box switches are the 400 gig variant switches, and then the green ones are the 800 gig, right? And so depending on what specific application or use, you could choose 32, 48, or 64. And another interesting thing to note about what I'm seeing a lot of customers do here is breakout cables. I know lots of people hate breakout cables, and I completely understand that. But the ability to transform a 64 400 gig port switch into 64 of 400 gig to 100 gig breakouts, you can get a lot of density and a lot of performance out of one switch. Although, again, some people would say the cabling mess is not worth it, but we give you that option. And one other thing too is this switch here on the right, the green bottom right, that's an OSFP switch, right? So you may have heard that QSFP or OSFP differences, but they can get cabled up in the exact same way. There's minor differences between both. Some of these Mellanox cards support OSFP. Some of them support QSFP, depending on what you need to connect and wire in. There's an option there for you. And then on the compute side, on the AI portfolio, we have the dense GPU server, which is the 885A. And this is for training pretty much only, right? So think of the 885A for training. This is 8 dense GPUs connected with SXM-based GPUs, as opposed to PCIe-based GPUs. And then on the right here, we have X series and also rack servers, right? So these are X series and C series. These are PCIe-based GPUs. And so the difference between SXM and PCIe, pretty simple. The SXM-based GPUs have NVLink within the server, right? So think of a 900 gigabyte per second interconnect within the server. Very high speed, but at the cost of using twice the amount of power of PCIe. So if you need it, great. But if you don't, it's just a waste of power. I have some sample reference designs to go over here. So typical network engineer background for me. Lots of Wireshark, lots of packet captures, lots of, path traces, trace routes, all those kinds of things. So in the context of infrastructure for AI, I think about it as follow the data, right? So instead of following the network path and MPLS headers and all that, follow the data. The source of the data could be an IoT box, it could be user data, it could be 50 years of medical data for your organization, whatever it is, right? And that needs to get transported somehow, some way to a data center, right? So it could be SD-WAN, it could be a direct connect, it could be whatever. And inside the AI-ready data center, this is something that we can talk about, but there's many different options in here, right? You could build it with Nexus and UCS, like I just mentioned. You could use even a combination of those with AI pods, if you've heard about that. There's also Hyperfabric that's just been announced here at Cisco Live. And then on top of that, we have different storage options as well. We have NetApp, Pure, and even hyperconverged with Nutanix, all validated designs. And then on the AI operations piece, using that data for something meaningful from an AI IT operations perspective, right? So we have Splunk as a data source for things like syslog, SNMP, NetFlow, and then from that, we can essentially, and I have an example of this, we can use that log data in Splunk to enhance our own IT operations with AI. And then on the outside of this, AI users. And now this got announced recently too, is Cisco AI Defense. This was a acquisition of Robust Intelligence. And basically what that allows is guardrails to be built around how users interface with the AI systems, right? So essentially, I follow the data. That's my viewpoint of it. Where does the data flow? What's the source of the data? Where does it go to? How can I, as an IT operations person, leverage that data? And then how does it get back to the user? So when thinking about infrastructure requirements for your private cloud AI data center, here are some of the questions to be asked, right? And there's no perfect answer to any of these. And I'll send out the slides. There's a WebEx space created, so don't feel like you need to memorize these. You'll get a copy, I promise. But essentially, what's the use case? Are you training, fine-tuning, RAG, or inferencing? And the reason why I call this out, right? Training requires a very dense GPU server with a lot of horsepower, right? It needs to be it's extremely expensive, extremely powerful. But what I think about is if you're just getting started with inferencing, you don't need that. It would be like me renting like a moving truck to go to the grocery store to buy like 4 apples. It's just completely unnecessary. And then think about the data that you're going to have, what kind of network you need, and where is it going to live. And that all impacts how much it's going to cost, what your accuracy is, and then all these different things. So again, you'll get a copy of this. Use this as you go talk to your business about how do you get started with this. Here's a sample reference design for inferencing. It's a standard leaf spine design for the front-end network. There's no need for a back-end network. Usually, 99% of the time. I've seen one instance with like a 405 billion parameter Llama 3 model where they wanted it, but it's not realistic to use that model for this. And then important piece, servers with PCIe-based GPUs. I can't emphasize this enough. The SXM-based servers use twice as much power than PCIe. So unless you absolutely have to have those, don't use them. And that allows you to scale based on your power budget. A lot of customers I talk to have power limitations of sometimes 10 kilowatts per rack, sometimes less, sometimes more. But each of these GPUs is 350 watts in a PCIe form factor. So you think 2 of those per rack server, another little bit of overhead, you're talking about 1,000 watts per server, easily. And then another interesting thing is GPUs handle all of the AI workload for the most part. So you can take any server that you're already deploying and just add GPUs to them. And now you can have them do AI and non-AI workloads on the same server. So you don't have to have necessarily a purpose-built server just for AI workloads, except for if you're doing training, but this is inferencing. Now for training, again, we talked about different kinds of backend networks. We talked about rail optimized and traditional flat, kind of 3-tier. And you really want to use an 885A or a dense GPU server for this. Again, it has 8 GPUs, flagship performance, SXM base for the high-speed interconnects. And depending on the scale, there are different storage options too. You could use local storage on the servers themselves. I've seen that plenty of times. You could have a separate high-speed storage fabric, or you could use some combination of the front-end network and the back-end network, just depending on what your storage requirement look like, how many interfaces you need at what speed. There's no best practice for this. It's just kind of where it fits, where it makes sense. And I will say, these servers, the 885As, they're absolute power hogs. They start at 10 kilowatts per server. Like most customers can barely fit one of these in a rack. So unless you absolutely need one of these, don't do it. Another important thing to note here is backend networks kind of start at 400 gig. And really, the thing to think about there is these GPUs are so highly performant that if you have anything less than that, like now, it's going to be a bottleneck just getting the data on the wire. And for front-end network in this environment, 100 gigs more than adequate. The only thing you need to worry about there is in and out traffic rather than the east-west GPU traffic. So, I talked a lot. How do you do this? How do you get started? How do you do it yourself? Building your own IT operations AI assistant, right? We had a little bit of a, let me build this out, a little bit of an animation goof. So here's a RAG example with Splunk, right? So retrieval augmented generation. So we have our sources of data here, right? Think you've got your Splunk database, you've got your ServiceNow instance, and then you have, all of your like IT operations, Word documents, spreadsheets with IP addresses in them, PDFs of, your manuals, your playbooks, whatever. And then you can feed all of that data in, and you can pull out, what are your logs, your inventory, your case notes, best practices specific to what you care about, and then think about an outcome, right? And a use case. For me, I see a lot of, call it, ticket grading as a use case, right? Like if I have a help desk agent, how can AI, like as a chatbot, enhance how they deliver their service? Or can they use this in a more streamlined way? And I'll give you an example of what that actually looks like here. Hard to see, I know. This is a screenshot from Splunk. So I'll read it. On the right here, we have this text here. This is log data, syslog data. Over here, we have the query from the LLM, right? So this is actually what's happening to my app and why was it down? How was it fixed? And the only data that I have to go off of this is the Splunk syslog data. And then based on the query and the data available in Splunk, it gives me an output here of saying, there was a interface down, it impacted the server and so on, right? So yes, you could absolutely go in, look at the syslog data, interpret it that, or you could give something like this to an help desk agent and then allow them to, understand a little bit better without having to escalate a ticket to understand what Splunk is trying to tell you. So what does that actually look like? Well, I hate to tell you, it's kind of simple. It's a server and Splunk. That's it. So on the server itself, it could be a C series, it could be an X series, whatever. And it just requires a little bit of software packages. And if you're not aware, most AI-based things run on Linux. with containers, and in this case, it would be the LLM module would be a Llama. You could run a Jupyter Lab, and you would actually have a vector database on the server itself, and you would use the Splunk search head with the data science and deep learning app. So Splunk has an app store if you're not familiar. You can go in for free if you have Splunk, download the app, install it, and then you just connect it with this UCS server, with the GPU. And that's all you have to do. And install these packages, and you're done. I mean, I set this up in like 20 minutes. So it's really easy to do if you have the components. So, okay, that's great. That's for getting started. But what about extending that? What about, how do we actually size AI infrastructure? Well, we have a sizer. So this is currently in, call it a beta phase for Cisco employees and also partners. But if you have a need for it, reach out to me, email, WebEx, whatever, I'll help you with it. So essentially, you take some of those parameters and sequence length and things like that, some of the things that are going to be available in a model card that we talked about earlier, right? You input that, and then you determine how many concurrent users do you need. In this case, I just did 200, and I picked an 8 billion parameter model, Llama 3.1, and I picked a 8-bit precision, right? And so I have two options here that I want to compare. I want to compare a H100, which has 80 gig of GPU RAM, and an L40S, which has 48 gig. And so the output of that is on the right here. And so it compares how many of these GPUs do I need to accomplish 200 users with this. And as it turns out, it's 2 for each, right? So then it comes down to, well, what's the performance look like? And so in AI world, time to first token is essentially you type in a prompt. Time to first token is when it starts telling you something back, right? So you'll notice when you use like ChatGPT, whatever, you type something in, and then it starts, slowly having things trickle out, right? So that time to first token is essentially the user experience. And so you'll see on the L40S, the time to first token is 4,000 milliseconds, so about 4 seconds. On an H100, it's about half that, right? So depending on is that acceptable or not, you can pick between these two different GPU options, right? And then there's other things that go into it too, but I mean, that's really it. Just know if you can find a model card and number of users, you can compare different GPU types for inferencing and get some performance metrics on it. And with that, I think I'm pretty much done here. So if you have questions, I'm in the space. I'm in the WebEx space for this session. I will be for another 2 weeks. If you have questions or you need to help size something, let me know. Happy to help. I don't think this session has a survey, but please generally fill out your surveys. It helps everybody. And if you want to learn more, you can book a session with me as well, meet the engineer. Thank you.
Am I audible? Perfect. Good evening, everyone. Welcome to this wonderful Cisco U Theater. Before we dive in, I'll quickly introduce myself. My name is Mohit. I work as a technical content developer here in Cisco's Learning and Certification. I'm a Cisco certified DevNet professional with 5 years of experience with various DevOps tools like Ansible, Terraform, and my personal favorite, Kubernetes, something I'm really excited to talk about today. How many of you have worked with Kubernetes before? Okay, that's a great number. And how many of you have deployed an application in Kubernetes, like a microservices architecture in Kubernetes? Perfect. Now, I know Kubernetes can feel a little overwhelming initially with so many components working together in different ways. But don't worry, I'm here to make the learning fun with examples and demos. We will learn Kubernetes by deploying a web application and discussing why we are doing what we are doing. So we'll be deploying a simple e-commerce application, a pretty classic example. And the architecture of the application is something like this. So we got a front end running. That is the Nginx server that would be taking in all the requests from the internet. And we have a Python backend, let's say a Python Flask application that would be taking in all the API requests and responding to them. We have a MySQL relational database that would be used to store all the user data. So normally, all the web application always follow this kind of architecture. They have a front end that is exposed to the users on the internet. We have a backend which take care of the API request and responses part. Then we have a database to store the user data. So we'll be deploying this application in a Kubernetes cluster. Before we start, there is a WebEx space created for this session. So if you have any question, please feel free to send your questions on the space. I'll be moderating the space till 28th of February. And after the session, I'll be there in the walk-in lab area, hall 3. So if you want to discuss something or clarify something, please feel free to drop by. I'll be happy to have a chat. Now, with the rise of containerization and microservices architecture, each application is deployed as a microservice. And each microservice has hundreds or even thousands of instances running. With so many instances running, there are challenges. One, how are you going to deploy these many instances? Two, how are you going to scale them? How will you upscale or downscale your instances depending on the incoming traffic? Three, what if some of your containers crash? How will you ensure your application is always up and running, always available to the users on internet? To tackle these challenges, we need a container orchestration solution. And Kubernetes is one such popular container orchestrator. It helps you deploy, it helps you scale, and manage your containerized application. But you all might be wondering, what exactly is Kubernetes managing? And this brings us to the fundamental unit of Kubernetes, pods. A pod in Kubernetes is the smallest deployable unit. It contains your containers that share the same network and storage environment. Assuming you have the Kubernetes installed, you have all the components up and running, you're all good. Now, to deploy a pod, you can go to your terminal. You can use kubectl. Kubectl is the command line interface for Kubernetes. You can run the command kubectl run. Let's say you're deploying the front-end pod. You can use the command kubectl run the pod name, and it's an Nginx container. So you'll use the Nginx image and expose your front end on port 80. Now, there are some problems with the CLI approach. One, it doesn't support all the Kubernetes configuration. And this is not reusable. This is not portable. You cannot give it to your operations team and ask them to run the CLI command and to deploy all your resources. And with very complex deployments, this command can get super long, making it very tough to understand and prone to errors. So a more efficient way, a more better way would be to use YAML files. So most of the deployments in Kubernetes is done using YAML files. And almost all the resources follow a similar structure of your YAML file. One, you have the API version, where you are going to specify the version of your API. Then you will write the kind field, where you are going to tell what type of resource you are going to deploy. Then you have a metadata block, where you are going to provide the details about your deployment. It can be the name of your deployment. It can be the labels. Labels are key value pair. They're optional, but they're always recommended. Labels help you with organizing your resources, and they also help you with selection. Selection is something we are going to discuss a little later, but right now you can think labels can help you with organizing your data, organizing your resources. So always a good practice to give meaningful names to your labels. Then you have the spec section. That is the heart of your YAML file, where you are going to specify all the details of your deployment. So for the front-end pod deployment, rather than using the CLI command, a good way would be to write a YAML file, and the YAML file would look something like this. You have the API version. It's going to be v1, and different resources behaves differently with different API versions. So always a good practice to refer the official documentation and select the API version accordingly. We have the kind field, so we are deploying a pod, so we'll write down pod. Coming down to the metadata block, the name of your pod is going to be front-end pod, and you can give it some meaningful labels like app, e-commerce, front-end. Going down to the spec section, here you have a containers block that would contain a list of containers. We are going to deploy a single container, that is the front-end container. You specify the image and expose your front-end on port 80. Now, before I deploy this, there is a very popular misconception that a pod can run only a single container, and that is not true. A pod, if you see, it's a list of containers, and it can contain multiple containers. But it is not a good practice to have multiple containers inside a pod. That's because, let's say, we have our front-end container and the back-end container inside a pod. And assuming something goes wrong with the front-end container, the pod would restart. And that would result in your back-end container to also restart. And so that is not something that you would wish to have. So we need to separate them. We need to isolate them from each other. I mean, that's the principle behind microservices architecture. To deploy the resource, you can go to a terminal. You can use the command kubectl apply -f for file, and specify your pod YAML file. Kubernetes will go ahead and deploy your pod. To see all the pods, you can use the kubectl get command. You can write kubectl get pods. It will list you all the pods that are running in that particular cluster. Now, if you want to see a lot more details about your pod, you can use kubectl describe. That can list you all the other details about that particular pod. Then, as I said, you can use label to filter your pods. You can use the command kubectl get pods -l for labels, and you can write down the label key value pair. It will list you all the pods that contain that particular label. To delete a pod, you can use the command kubectl delete pod and the pod name. So similarly, you can deploy your Python backend application as well. Similar stuff, API version, kind, metadata. And here the container is going to be the backend container with the, let's say you have version 1.0 right now. So you can use my backend app 1.0 and expose your Flask application on port 5000. To deploy this pod, you can use the command kubectl apply -f and the file name. Now moving on to the database file, this is little different. Here we have a couple of changes. To run a MySQL database, you need to pass some configuration parameters. Parameters like database name and your database password. We are going to pass these configuration parameters using environment variables. You can write your MySQL database key and provide the value as e-commerce. But if you see, the value of the name of your database is written in plain text. And we cannot use the same for our password. Writing down your passwords in the YAML file is a huge security risk. Anybody who has access to the YAML file can see your database password. So a good way to tackle this would be to use secrets. Secrets contain your passwords in a base 64 encoded string. And you can write down the key of your password, and the value from it is fetching your password is a secret. And it's a base 64 encoded string, and encoding is not a very secure way to write down your passwords. It's very easy to decode it. So to enhance your security, you can encrypt your etcd data store where Kubernetes usually store all the resources and all the configurations. So a good way to always also impose role-based access controls to limit people accessing all your secrets and all the other resources. And the second change we have made is in the volume mounts. So by default, Kubernetes is going to store all the data inside your container. So if a container crash or if a container restarts, you would lose all the data. Because right now the data is stored in a container. But that is something you don't prefer for your containers where you're storing the user data. So a good way to tackle this would be to use persistent volumes, volumes that exist independent of the life cycle of your container. It can be your network file system, or it can be a storage provided by your public cloud, Amazon S3 bucket, or it can be your private data center. To specify that volume, you can use persistent volume claim, in which you are going to request the minimum amount of storage you would require to run this particular pod. Let's say you need 5 gigabytes to run this pod. You can specify that in the persistent volume claim. And while deploying it, Kubernetes will scan all the persistent volume and find you the volume that has minimum 5 gigabytes. So to deploy this, you can use kubectl apply -f and the YAML file name. So right now, our current deployment looks something like this. We have a single instance of our Nginx server exposed on port 80. We have a single instance of our MySQL database on port 3306, and a single instance of your backend application. They are all part of a single cluster. That means they are all part of the same network. That means you can access any pod from any of the pods. Let's say you want to try to go inside a front-end pod and check if you are able to reach the backend pod. You can use kubectl get pods -o wide. It will suggest you all the IP addresses of that particular pod. The IP address of the front-end pod is 1024.02, and the IP address of backend pod is 1024.03. You can use the exec command, kubectl exec -it, and access the terminal of your front-end pod. That will take you into the front-end container that is running. And to check the reachability, you can use ping and ping the IP address of your backend pod. Now, one thing in Kubernetes is your containers have a very short lifespan. They would keep crashing. They would spin up with the different IP addresses. So it's not good to rely on IP addresses. Rather than that, we can use the pod name. So even if your containers come up with a different IP, they would always come up with the same name. And Kubernetes will automatically resolve the name and fetch you the present IP, and you will be able to reach the backend pod. So it's not a good practice to rely on the IP addresses. It's good to use the pod name instead. So right now, we have only a single instance of our front end, a single instance of our backend, and a single instance of our database. But is a single instance really enough to handle the traffic? Will it be able to handle all the traffic that is coming from the internet, just like one container running for each component? No, right? So we need to manage our Kubernetes application at scale. And there is one more limitation. If your pod fails or if your pod is removed, it will not restart automatically unless there is something that is managing it. And that something in Kubernetes is called as deployments. Deployments uses a declarative approach in which you are going to specify what is the desired state of your deployment, and Kubernetes will work internally to keep that same state. So let's say if you are deploying 3 instances in your deployment, if you manually remove one, Kubernetes will automatically spin up another one to maintain that number. To create a deployment, we'll again write some YAML files. In this, the API version is going to be app/v1. It is different from what we had for pods. The kind would be a deployment. It's not a pod. And in the metadata block, you are going to specify the name and the labels. Now, coming down to the spec section, you have a field called replicas. In replica, you are going to write down the number of instances you would like to have for the particular pod. We are going to write down 3, so there would be 3 instances of the front-end pod running. In the selectors block, you are going to define the selection criteria. And here we are using our labels. As I said, labels can also help you with organization, but they can also help you with selection. So all the pods that would match with that particular label would fall under that deployment. And if you see the labels defined in the criteria and the labels of the front-end pods are matching. So in the template section, you are going to have the similar pod YAML file where you will write down the metadata, and you are going to write down the container definition. You'll use the Nginx image. You will expose your application on port 80. But here, there is a small change. We are not writing the name of the pods. Usually, whenever you'll deploy your pods using a deployment file, the name of the pods would be your deployment name and a unique identifier attached to a pod. And this is something we'll look into a little later. So Kubernetes, so if you deploy this file using the command kubectl apply -f and the file name, you will have 3 instances of the pod running. So there are some key advantages of using deployments. One, you can upscale or downscale your instances anytime. You can use the command kubectl scale deployment and deployment name and specify how many replicas of that particular pod you would like to have. So if you write down 5, Kubernetes will deploy additional 2 to maintain that number. And if you want to verify, you can go to kubectl get deployment and the deployment name. And you can see there are 5 instances running, with 5 of them are available. Now, it can also be used to update your application. Let's say your development team is coming up with a new version. They made the changes, they pushed the code on the GitHub repository, and now a new Docker image is available, and you want to update your application. You can use the command kubectl set image. You can specify the deployment name and for which container you would like to update the image. And you can give the new image name. And Kubernetes will deploy your application in such a way that there will not be any downtime. So let's say if you have 5 instances running, it's going to take 2 of them down. It will replace them with a newer one. Then it will take the rest of the 3 down. It will replace them with a newer one. And this is called rolling strategy. This is different from a recreate strategy, where it will take all of them down and replace them with a newer one. And that we are going to have a downtime. So by default, it is always rolling strategy, unless you explicitly mention. And if you want to see the history of your rollout over the entire course of deployment, you can use the command kubectl rollout history and the deployment name. You can see the changes you have made and along with what all things have been changed in that particular revision number. Let's say something goes wrong with your particular deployment, you can roll back using the command kubectl rollout undo and the deployment name. It will take you 1 revision number back. But let's say if you want to go to a specific revision number, you can specify the 2 revision argument and give the revision number. And all this is done with no downtime. So our current deployment looks something like this. So right now you have 3 instances of your front end, 3 instances of your back end, and 3 instances of your database. And it is all self-healing. If you manually delete one pod, Kubernetes will automatically spin up another one to maintain that number. Now, as I said before, you cannot rely on your IP addresses because IP addresses keeps changing. So a good way to deal with that was to use pod names. But here, even the pod names are not reliable because pod names, I mentioned, we don't specify the pod name in our deployment. It will use a unique identifier for all the pods. So if a pod crashes, it will come up with a different name. To solve this, we need to bring all the pods under a single umbrella. And that single umbrella in Kubernetes is called services. So these are the 3 primary services provided by Kubernetes. Cluster IP. Cluster IP is always used for pods that want to communicate internally. You don't expose these instances outside the container, outside the cluster. Then you have a node port service in which you are going to expose a particular port of your node, and that can be used for internet access. And the third service is load balancer, in which you can integrate your public cloud load balancer for external access. So in the architecture, we only exposed our front end for the for the external access, but our backend and database always stay within a cluster and they are not exposed to the internet. So we are going to use load balancer service for the front end, but we are going to use cluster IP for our backend and our database because they are not exposed externally. To deploy a service, you are going to write a YAML file. Here, API version and the kind of the deployment is a service. In the metadata, like to specify which all pods fall under that particular service, again, it is done using labels. So if you see all the pods that would contain that label would fall under that particular service. And the labels are matching with our front-end pod. And in the spec section, you are going to define what type of service this is. This is a load balancer service. And selection is done using labels. Then you have a ports block where you're going to specify the port of your service and the target port. So if any request that would come on port 80 of this service would be redirected to port 80 of your pods. So port 80 is where the Nginx service is running for our pods. And services always help you with layer 4 routing. So the protocol can be TCP or UDP. Similarly, for our backend service, the type of service is going to be cluster IP. It's not load balancer because we are not exposing our backend component to the internet. It's going to be cluster IP. Selection is done using the labels of our backend pods. And the port of the service is 5000, and any service that would come on port 5000 would be redirected to the port 5000 of the pods. I mean, the port and the target port should not be same, but just to keep it consistent, it's a good practice to use the same port numbers so that it will be easy for us to debug in future if something goes wrong. And we can deploy these services using the command kubectl apply -f and the file name. So our current deployment looks something like this. You got a load balancer on the edge of your cluster. Any request that would come in would be load balanced between all your nodes. It can be round robin, or you can choose any algorithm you would like to use to balance your traffic. And any request that would come on port 80 of our front-end service would be redirected to port 80 of your pods. That is the Nginx server. And our front-end can communicate internally using cluster IP service. And again, we are going to use the service name rather than using the service IP, because services can also crash and they can come up with the different IP addresses. So we're going to use HTTP backend service and port 5000. So the request that would come on port 5000 of our backend application would be redirected to port 5000 of our backend pods. And they can also communicate internally within the database and the backend service. So this is a good deployment. I mean, it's not a very perfect deployment. Before I wrap up, I would like to conclude by saying there is a lot more things you can explore on your own in Kubernetes. I would highly recommend learning ingress controllers. Ingress always let you do layer 7 routing. The routing is done depending on the HTTP request that is coming. So it would do a regular expression matching with the HTTP request, and accordingly it will redirect your traffic. Say, in case of Amazon, if it is, say, Amazon Prime Video, Amazon Music, or Amazon Shopping Cart, depending on the HTTP URL, it will match your request and it will accordingly redirect it to the services. Now, if you want to learn more on Kubernetes, Kubernetes is part of our DevNet track. And you can always go to Cisco U to learn more about the DevNet automation and network programmability. We can also explore our Cisco U tutorials, Cisco U courses, and specialized custom learning tracks. So a great place to learn, to upskill, and certify yourself across various Cisco technologies. So yeah, that's all, guys. Thank you. And if you have any question, you can let me know. Thanks.
Hi, everybody. Hope you can hear me okay. Welcome to this session, which is all about closing the loop, automated assurance, so discovery and assurance for Cisco networks with NetBox. My name is Rich Bibby. I'm a technical advocate at NetBox Labs. I'm based in the UK, and very grateful that you're all here today to hopefully enjoy what's going to be a decent demo. So the agenda, quickly, I'm just going to talk about who is NetBox Labs in relation to NetBox. Also, we'll cover briefly what is NetBox for people that aren't familiar with the product. We'll talk about what is a network source of truth. You probably hear this quite often these days, particularly in the realms of network automation. So we'll just define what is a network source of truth. Then we'll look at what is operational drift. So we'll dive into that, and then we'll show you how to get operational drift under control with a new feature for NetBox called NetBox Assurance. And I'll demo it all. We'll put it all together in a demo so you can see it in action. Okay, so first of all, are there many people here that actually use NetBox themselves? Yeah, okay, that's fantastic. So, as the slide says, everybody uses NetBox, including Cisco. And yeah, NetBox is seen in networks of all shapes and sizes all over the world. This is a mixture of some NetBox Labs customers that are using NetBox Cloud and NetBox Enterprise, and obviously there are some big open source users of NetBox as well. So NetBox Labs, we're actually for those that aren't familiar, we're the commercial stewards of the NetBox open source project. So we were founded in New York in 2023, so a couple of years old now. We are the commercial steward of the NetBox open source project. We have a world-class team. We like to think that, first of all, built and led a company called NS1, and also founded the NetBox project. Those of you familiar with Jeremy Stretch, obviously Jeremy is very much part of the scene here at NetBox Labs, one of the founders. We've got some great investors and some great customers, and as I say, what this allows us to do actually with the commercial offerings we have for NetBox now is to reinvest back into the open source NetBox project. So, we have more dedicated engineers now that are just working on the NetBox open source project, and that allows us to do this because we're able to reinvest the profits, if you like. Okay, so let's define what a network source of truth is. So, it defines the intended state of your network. So what we mean by that is that that's very different to the actual state of the network. As we know, your monitoring tools and your assurance tools will pick up the actual state, but we want to define the intended state. So that's what we, as the network engineers, the network architects, are actually saying, this is how we want our network to be configured. And that's what we use, that's what our source of truth is. It should act as a single, consistent data set. And we also find, actually, when people start to move to NetBox, sometimes there can be a bit of a mental shift, which was that moving away from things like using spreadsheets, files, with network data, IPAM data, DSIM data. Dave, who left the company 3 months ago and knows all about the Nexus switches and things like that. So we're moving away from that, and we're documenting everything in NetBox as a single source of truth. And the source of truth then becomes the authoritative reference for that network data. And it can then drive network automation as well, as I'll come on to in a second, and we'll see this in action. NetBox is the world's most popular network source of truth. That's definitely fair to say. It has a hugely comprehensive data model, which can model everything from ASNs through to VPNs and everything in between. It's hugely extensible, so there's a great API. It's very easy for other systems to interact programmatically with NetBox. So there's massive extensibility that comes along with that. And there's an enormous ecosystem of other tools that will work with NetBox. Now, we see our customers actually, and most people adopting NetBox as being on a journey through these 3 stages. So you see most people, I think 72% there, are in between phases 1 and 2, which is they are getting rid of their legacy documentation. They're consolidating things down into a single source of truth, i.e. NetBox. And what that allows them to do then is actually then move on to phase 2, which is to start to model that data correctly. And what I mean by modeling is, so you're bringing together your IPAM data and your DSIM data, having it in the same place, and you're able to link that data using the relational database that is NetBox. Once you've gone past the modeling stage, you can actually then start to automate, because you use the data that's in NetBox as your source of truth, And then your automation tools will then talk to NetBox to extract the data that they need to push configurations out to the network devices themselves. So you can see you start to sort of build a platform in stages 1 and 2, and then you can move on to network automation that you really build around the platform that is NetBox. There's a few versions of NetBox. I'll just cover these briefly. You're probably familiar with the NetBox Community Edition there, but we've also got NetBox Enterprise and NetBox Cloud, which are offerings from NetBox Labs. So with NetBox Enterprise, this would still be run by yourselves on your own infrastructure, but we would support you. You get advanced features, so you get things like integrations with other systems like ServiceNow. You get change management, so extra things that you can layer on top of the Community Edition of NetBox. And then you've got NetBox Cloud as well, which is basically you just consume NetBox as a service. So it runs in our own cloud infrastructure, and again, supported by us. Automatic database backups, automatic upgrades, all that good stuff is taken care of for you with NetBox Cloud. Okay, so I'm going to move on to just talk a little bit about operational drift and just define what we mean by this. So the operational drift basically is the difference between what should be and what actually is in the network. So it's what's out there versus what you've defined in NetBox as your source of truth and your intended state. So we know few teams have actually got the ability to automatically discover what's out in their network. But what should be in your network? That's the question. So we call this the intent. So it's your design, as I've already mentioned. It's you as the engineers and the architects are saying this is our design, this is the intended state for my network. And then operational drift is where there's a difference between your intent and what's actually out there in the NetBox. And that's what we're going to explore a little bit now and show you how NetBox assurance can hurt with that. Why does drift hurt? Well, basically, it can cause all kinds of problems. So imagine you've been asked to make a change in the network, you SSH into that device, and then you find something that you didn't expect, like maybe an IP address is wrong, an interface is in a state that it shouldn't be in, an interface is in a different VLAN that it shouldn't be in, things like that. So you're now dealing with an unexpected situation. So what we want to do is really minimize this amount of operational drift between your intended state in NetBox and your actual state that's out in the network. So what we've introduced is a couple of new features for NetBox. So first of all, you've got NetBox Discovery, which makes it easier to discover the operational state of your network and actually ingest that data into NetBox. Prior to having NetBox Discovery, those of you that are familiar with NetBox, you might be aware that if you wanted to add a new device into NetBox, you've got to do things like make sure the manufacturer exists, so make sure Cisco exists, make sure the device type exists, make sure the device role is already predefined. But what NetBox Discovery allows you to do is actually just send data to NetBox, and it will take care of all those relationships for you and add objects into the NetBox into the database in the right order. So we'll have a look at that in a second in the demo as well. And what NetBox Assurance then allows you to do is actually get control over that operational drift that we've been talking about. So, we as network engineers want to have a look at what data have we discovered out there in the network, and how does that compare to what we actually think should be in the network? And that's what NetBox Assurance does. NetBox Assurance is actually in private preview at the minute, so we're working with our customers to refine the offering. So it's not generally available yet, but you're going to see it in action. But it is coming, but currently in private preview. So just bear that in mind. Okay. So NetBox Assurance gives you a unified control plane as well. So what we're talking about here is we have NetBox in the center of this automation architecture here. So it's the source of truth. We have down at the top left we have NetBox Discovery, which again is discovering the network devices and ingesting that data into NetBox. What we want to then look at down at the bottom left here with NetBox Assurance is actually what's the difference between the intended state and the actual state, and that's what we'll see in a minute. What we also see then, if you follow the loop round, is you've got your automation and orchestration tools down at the bottom right. So tools like Ansible, for example, which we'll see in the demo in a minute, is going to have a webhook sent to it to then trigger an action on behalf of NetBox. So then Ansible is going to talk to NetBox, get the data it needs to then push out to the Cisco devices out there in the network. And we go round in a circle. So ultimately that's where we need to get to. And NetBox Discovery and NetBox Assurance actually help people get there. Okay, so I'm just going to mention briefly, because what you're going to see in action in this demo is the Ansible collection for NetBox. I use it in the demo. Hopefully most of you are familiar with Ansible and the Ansible collection for NetBox. It's an amazing collection. It's got lots of use cases that you can get from it. It's now officially supported actually by NetBox Labs and Red Hat for our joint customers. And that's a recent thing that happened last year. Obviously it's available from the certified collection is available from the Ansible Automation Hub. You have modules to define the intended state in NetBox, and then you've got plugins to drive the automation of the network using data from NetBox. Quite a simplified diagram here a little bit. So you can see, NetBox is used for the network inventory. So the Ansible collection talks to NetBox to get the inventory, and it's also used to define the intended state. But then it's also used to take the data from NetBox and push it, configure the networks, either to a controller or by directly onto the interfaces themselves. And we're going to make use of an extra feature in NetBox here, which is webhooks. So we're going to see a webhook get fired to event-driven Ansible to trigger some automation. Now, our scenario here is that we have a site in Amsterdam, and we're going to discover some IP addresses, and we're going to discover some new devices that have appeared on the network. We're going to ingest that data into NetBox. We're going to view that data. We're then going to merge it in and then trigger we're going to trigger a playbook in Ansible that's actually going to push out some config to that device as well. So we've got a Cisco device, a CSR1000V, I think, running in Container Lab. So I'll just kick off the slide here, the video, and I'll talk you through it. So first of all, we have our site in Amsterdam. You can see there's nothing in there. We've no devices, no prefixes, nothing else, but we have a site that's active. Now, a great feature of NetBox is something called configuration contexts, where you can store data in JSON format that would apply to certain areas of your network. So what we're saying here is that these NTP servers, syslog servers, name servers apply to every device that's at the Amsterdam site. And you can define this, at whatever level you want to within NetBox. And you can use weighting. And as I say, we've applied it in this particular case to the Amsterdam site. Now, another great feature of NetBox we're going to make use of here is event rules. So what we're looking for here is something that's happened in NetBox, and then we want to take some action on the back of it. And in this case, what we're looking for is the merging of a branch of the NetBox database into the main NetBox database, and that's going to trigger an action. So we have an event rule here. And you can see this event rule is being triggered when a job is completed, and it's merging of a branch into NetBox. And the trigger, or the action, is a webhook. So we're sending a webhook to the Ansible automation platform, which is listening for events coming out of NetBox. And what we're going to see in a minute when we run the discovery is that this will actually trigger an event. It will send the webhook to Ansible, then Ansible will run the playbooks. Okay, so moving on to assurance. What we're looking at here, we've got some existing data in here at the minute. These are the deviations. That's the drift between our actual state and our intended state. This is just a bunch of sort of dummy data that's in here at the minute. And what we're going to see in a minute when we actually run a new discovery run using NetBox Discovery is that we're going to ingest some new data. So what we've got here is Ansible, event-driven Ansible. It's listening for webhooks coming from NetBox. Very simple configuration we've got here. It's listening on port 5000 on all its interfaces. And we're looking for, you can see the payload content will be job ended, and the model will be branch. And if you could see, it's just been cropped off the end there, but we're looking for the device added text to be in the webhook as well. So Ansible EDA is listening. When there's a match, so when the webhook is received by Ansible, it's going to kick off this playbook. I won't go into the actual code of the Ansible playbook. It's pretty standard stuff. But all we're going to do is take the data out of NetBox, take the NTP data, the syslog data, and so on, and apply that as a configuration onto the devices in NetBox. Now, this is the discovery agent for NetBox. So what we're doing, we've got a simple discovery configuration. We're going to scan this subnet 172.24.0.0, and we're just kicking it off here. So it's spinning up a Docker instance which is running the discovery, scanning all the hosts in the subnet, And what we can see now is we've discovered a couple of new IP addresses that we can see on the network. So this is what, when we click in, when we drill down a level to see this, this deviation, we can see we've discovered a new IP address. This is the IP address of my router in the lab. And you can see what this gives you then is a change set that's going to be ingested into NetBox in a minute. Now we've discovered this device, what I want to do is run device discovery and actually query the device. It uses Napalm under the hood. It's going to talk to the device. It's going to figure out what kind of device it is. We know it's actually a Cisco iOS device, but I've commented it out, so you can just see it will interrogate the device and work out what it is. And then it's going to take that information that it's gathered using Napalm, and then we'll see it ingested into NetBox Assurance. Okay, so there's a few things we've got now. You can see we've got a new device, the CSR1 has been discovered, and this is that data. So we're talking about the manufacturer, the platform, serial number, the site, and its status. And this is the new data that's going to end up in NetBox in a minute. You can see the changes when we kind of drill down a little bit further, and we can see exactly the change set that is going to be written into the NetBox database in a couple of minutes. So we'll just go back to the overview there. Now if we go back to deviations, what else have we got? We've got an interface. So we've got Gigabit Ethernet 1 has been discovered. So you can see here's the data for that particular interface. It's related to, it's related to that device itself. We can see the MTU, the MAC address, the speed. If there was a description configured, you also see that there as well. And I think we have, I think there's a prefix and an IP address that's part of this data set as well. So you can see we have a new prefix that's been discovered as well. So now, okay, so we've got some new data. Let's do something with it. And this is new data. It's different to what we've seen on the network before. So what do we want to do? First of all, we're going to create a new branch of the NetBox database. So we're going to create a new branch here called Cisco Live. And then that allows us to work just in that branch before we actually commit any data to the main NetBox database. So we're working in this branch. And now what I'm going to do is link this branch to this newly discovered device data. Because we don't just want to ingest it straight into NetBox. We actually want to verify this network data first. Is this actually our intended state? And in fact, it is, because we've deployed a new device in Amsterdam. So, okay, what we're going to do here is we're going to run a rediff here, because obviously if you think about this discovery process might be running overnight on a scheduled basis. So we just want to check, okay, let's just rediff it again, make sure it's in sync with the state of NetBox now. And at that point, we apply it to the branch called Cisco Live. Now the next step, because we're happy with this, is we want to move ahead now and actually write or apply that data to the branch. So we select those objects. We're going to say we're going to apply that to the to the Cisco Live branch. And we'll apply these 4 deviations. Okay. Just checking we're doing okay for time. So we've applied those 4 deviations. And you can see in the top right corner there, you can see which branch of the NetBox database we're working in. So we're now we've switched into the Cisco Live branch. And then in a second, we will actually compare the branch. And you can see the difference between the main NetBox database and the data that's in the branch. So we'll go to the Amsterdam site. We can see now we have a new device and we have a new prefix. Now these weren't there at the start of at the start of the demo, as you know. So we're going to take this information. So you can see we've got a new device here. It's the CSR1. It's a CSR1000V. It's in Amsterdam. It has interfaces. So we've discovered NetBox Discovery has been able to gather all this information from the device itself. And now, in a second, we're going to write this to the NetBox database. Okay, I think it might show us the prefix as well. But if we go back to Amsterdam, yep, you can see we have the 10/24 prefix that we discovered as well. Okay, so great, this is all good. We're now happy, so we're going to view the branch. We're going to compare the difference between our branch and what's in NetBox currently. So we can look at the diff, and this shows you a nice change set. So you can see, okay, we've got the new IP address, the interface, the device type, and the prefix as well that's going to go with it. Now we know, looking at this, because there are 5 new things here. We're 5 changes ahead of what's in the main NetBox database. And if you're going through the process of actually looking at this data and making sure that this matches your intended state in NetBox, you can dig into this data and see what we've got. Now, I'm happy with this, so I'm going to commit the changes and merge the branch into NetBox. Now, if you remember, we have the webhook that's going to fire, and we have the event-driven Ansible, which is listening for a webhook coming from NetBox. So we've merged the branch in at this point, and in a second we'll actually flip over. So here we go. So you can see the webhook's been received, the Ansible playbook is now kicked in, and what we're doing is we're taking data for syslog, name servers, and so on. We're taking that from that config context data in NetBox, if you remember that, and we're pushing that out to the network device itself. And this is where the Ansible collection for NetBox comes in, because it's using the inventory data that it's got in NetBox to do this. And the final bit of the demo is me logging into CSR1, doing a show run, and we can see name servers. We can see on the next screen, we can see logging hosts. We can see the login banner, and we can see our NTP servers. All of this information has been pulled out of NetBox. This would be maybe bootstrapping a new device that we've discovered, just give it some basic configuration for the network services that it needs to access in Amsterdam. Okay, so that's the demo, and let me just flip to the next slide. So I talked about something called NetBox Discovery. A great way to get started with NetBox Discovery, because this is open source. You can do it with NetBox Community. Check out the NetBox Discovery Quick Start Guide. What you can do with this is actually spin up a lab with some container lab devices in it, run NetBox Discovery, ingest that data into an instance of NetBox. It's just like you could spin this up in, say, a DigitalOcean instance, spin up a box, spin up this, and you can have a play around with it, and you can see how it works. The feature that I showed you, NetBox Assurance, just remember it's in private preview at the minute. It was only released to me last week to actually be able to demo it here in the state that it's in. So you've seen it. It's brand new, and we're working with customers and partners to get feedback on the NetBox Assurance feature. If you're interested in getting started as well with NetBox, the easiest way to do it these days is just go with the NetBox Cloud free plan. You can have, I think it's 100 devices, 500 IP addresses, and 10,000 API requests. You can spin that up for free, and it just probably take you about 60 seconds, and you can have a NetBox Cloud instance up and running. Any questions? You're more than happy to take emails from you. If you want to reach out to me, that would be great as well. And yeah, that's it. So thank you very much for watching. Thank you.
Can you hear me? Oh, yes, the microphone is on. Okay. Hello, everybody. How are you doing today? Yeah, good? Happy faces? Aspiring CCIEs, everybody, I imagine, in this session. No, not really? Okay. Well, at least one say yes. That's a success.
And if you are a CCIE, then we're going to make you multiple CCIEs by
That's
the end
it,
of
yeah.
this. Okay.
It doesn't stop at one. So, hello, my name is Elizabeth de Rocco. I work for a company called NIL. We are part of the NIL learning team. We're a learning partner for Cisco. We've been a learning partner for many, many years.
And I'm Brad Thomas. Pleased to meet you. I'm one of the directors of NIL South Africa, Sub-Saharan Africa. So pleased to meet you all.
Good. So, first of all, I'm going to tell you a little bit about who we are, just so we gain your credibility. This is my hidden agenda here, that you know that what we're doing has a reason why we're doing this. Now, NIL was founded many years ago when Cisco was an infant. So 35 years ago, NIL was founded. And very soon after, we also became a learning partner. So we've been doing Cisco technologies for many, many, many years. You can see some of our milestones over there. I'm not going to bore you with that, but you can see the trajectory is very long. And a few years ago, starting with our team in Africa, we actually created a program called Project 525. And this project was actually very, very successful right from the beginning. And we actually won an award in that same year. And the first batch of graduates from this program, because this is like it's like taking a university course, right? It's really, really heavy training. And the first batch of those graduates that achieved the CCIE certification came out in 2024. I was there. I was invited. Brad was the brain behind that graduation ceremony, and it was the single highest number of CCIEs awarded at a single time. How many were there, Brad?
There was about 22.
22 people got their CCIE at one time. Cisco certifications team came over. Everybody was very, very happy, right? So we've been doing this for a long time. We've been learning partners for many, many years. Now, did you hear, were you at the plenary session today? Yeah? Did you hear Oliver talking about the CCIE certification? CCIE certification has been the most prestigious certification from Cisco. Inside the IT industry, it's really, really highly regarded. A lot of people aspire to become a CCIE. Not everybody makes it. Cisco makes it a difficult certification on purpose. They really want you to know your stuff. They time you. They make it actually timed, so you know that you only have a limited amount of time to make that happen, to pass that exam, because when you're troubleshooting a real network, that will happen. You will actually have a customer breathing down your neck telling you, or it's your own network, and you have your manager breathing down your neck and telling you this needs to work right now. So that's why this certification has been created as it been, is to give you the skills that you need to do a really difficult job, to be an expert on your field. Now, when people are preparing for the CCIE exam, a lot of the times they do it on their own, right? There's been a few programs for Cisco. There's been a few programs that you find online, boot camps or the like. But a lot of the time you're on your own. You are studying on your own, creating your labs on your own. And it usually takes 2 to 3 years for somebody to prepare, right? And I've even seen people that have taken the exam several times and they've given up because they are doing it on their own. So this is why we are taking a slightly different approach. So the reality of how you study when you're preparing to your CCIE, right? You need to sacrifice time. You need to make a conscious decision that you're gonna spend some of your time studying to become a CCIE. And you need to know that this is gonna be a sacrifice of time that you would otherwise spend having fun with your family, with your friends. So that's one of the things that you need to make a decision. The reason why you do it, it's a life decision. This is not just a tick in the box, a little thing that you do for work. You have chosen to become an expert. This is going to be your life, right? This is going to be who you become, right? This is not only that sticker of CCIE. You're now an expert in networking. That opens up doors for work. That gives you prestige inside the company. That opens up colleagues as well. You become part of CCIE clubs and things like that. So it is actually a life decision that you're making. When you're studying, you have the pressure of the time. You're nervous during the exam. You know that you have the exam book for this day. By then, you need to be ready. So there's a time constraint associated to it as well. You need to have a very structured approach. If you're studying on your own, this is difficult, right? So this is one of the things we took into account. You need to have a structured approach. You need to manage your time really wisely because you don't want to spend 10 hours learning something that should be simple. You want to make sure that you are spending the time on the things you need to spend them, right? And it's difficult to pass. And sometimes it's weird to find out what was the problem. Sometimes people don't read the whole exam, and that takes them more time to solve it because they didn't know that on step 10 they need to do something in the same machine that they needed to do in step 1, and they need to go back and reconfigure because they didn't read the whole exam. That's a common problem. Another common problem is overconfidence. A lot of people prepare a lot, and they think, I know it, but they haven't actually prepared for the exam. The exam itself has its own quirks, let's call it, right? So overconfidence can be your enemy here. So we have even taken this into consideration to this program. You require passion, patience, and perseverance. Without that, you're not going to get your CCIE. With all of these components in mind, right, we started a story to work on a CCIE program. And now I'm going to pass on the ball to Brad, and he's going to tell you what is Project 525.
Thank you. Okay, so where does 525 come from? I think that's a question on everyone's mind. The intention around 525, which I'm a bit far away here.
I think you're going to have to stand a little bit closer. That one, yeah.
Okay, there you go. So the intention around 525 was to address a skills deficit that we have in Africa. Okay, so from South African point of view, we saw that there was a very limited amount or a massive exodus of expert type skills out of the country. In fact, it filtered right the way down into CCNP, CCNA. And whenever an opportunity came for somebody in Africa to work across in Europe or the US, they would take that opportunity because it was very lucrative for them. But we needed to reinvest in it. And here you can actually see how it's actually broken down. And these are real estimates that we kind of came up with to say, okay, in Australia, there's CCIEs, there's about 900 CCIEs. UK, 950 CCIEs, these are just estimates. And in the USA, as much as 6,000, and so it goes on. Now, the scary statistic is that if you look at the continent of Africa and the true size of Africa, a lot of these countries in real life actually fit inside the continent of Africa. And there's 1.2 billion people in Africa. And the scary statistic, I've got to stand here.
Yeah, let's switch.
And the scary statistic is that there's only 300 CCIEs in the whole continent of Africa, not just in South Africa. So the concept was created for us back in 2023 to say, by the end of 2025, we want to have created 500 CCIEs in Africa by the end of 2025. There's your 525. Now, we didn't expect it to gain the kind of interest that it's got on international markets. Okay, so we've had a lot of interest coming out of the Middle East, where we've already started a cohort in the Middle East as well, very successfully with our counterparts there. And then we were taking it into the European market with obviously our company in Europe. And now we're actually looking at the broader market as well. So the intention around Africa was to build it. Now, we've run this program very successfully. There's a very high first-time percentage failure rate. For those of you who have done your CCIEs, you'll know exactly what I'm talking about. To attempt it the first time is very difficult. The structure around it is what's required, and that's what we've put into this program. Now, what's important is that we haven't done this ourselves as NIL. What we've actually done is we've collaborated with Cisco's Learning and Certifications team, who have been phenomenal in assisting us to actually construct this program. So it's not something we've just built together and basically taken to the market. We've collaborated with Cisco to put in as much as possible into the program. And that has massive benefits for companies. So if you're a decision maker within an organization, we've managed to do it as a derivative work with Cisco Learning and Certification. So you can use your Cisco Learning credits for a CCIE to get your CCIE, or you can pay cash if it comes out of the HR budget as well. So that's where it basically came from, the analogy 525. Now, just to give you some statistics, Elizabeth mentioned a little bit earlier that we started running it in South Africa. We currently have over 200 delegates on the program. Out of the delegates that we've run for CCIE on the program within a very short period of time, and Elizabeth's going to go through the construct of how we've built it out, which is 12 months, we've managed to get 78.5% success rate. Okay. And if I told you what the percentage was for first-time failure rate, it's really high, and it's probably only 7% pass rate. So we kind of changed that dynamic significantly, giving everybody who embarks on a CCIE journey to have the best possible opportunity of becoming successful, hopefully first time around. That's our ambition, that's our goal. And then out of the project, you can see 80% completion. So some people drop off. Some people have life issues. But we have it as a structured, mentored program that addresses that and helps those individuals keep up with the program as well, which we'll delve into in a little bit more detail in a short while. Now, for those of you who have done CCIE, you've a legacy CCIE, you've had it for 15 years, 10 years, 5 years, whatever the case may be, you would have done the original version. Also, what we've done is we're doing it as the 1.1, so a lot of you will know this, this image, but this is the enterprise structure. Now, if you look on the right-hand side, there's two different modules when you're doing your CCIE exam, your lab exam. There's module 1, which is design, and then there's DOO. There's 3 hours for your module 1, and there's 5 hours for module 2. And what's difficult about module 1 is you'll see there's no backward navigation. All right, so we kind of prepare the individuals to understand what to expect out of this, and we have very much involvement from Cisco's learning and certifications to help the engineers to actually understand what they're going to expect. So much so that we built in an actual mock lab of the actual CCIE lab exam into the actual program. So you'll sit for 8 hours and actually do the mock exam prior to actually doing the final lab exam, over and above all the other components that we've included in the program itself. But the one big stumbling block that we've picked up out of this program is the ability for the engineers, especially the legacy engineers who are very skilled in what they do, to actually adapt to programmability and automation. So we've had our first cohort that was very successful. We had a lot of engineers go through the program. The biggest stumbling block on that program was when they got to automation and programmability. And so what we do is we actually inject instructors into the program to actually assist at that particular junction. So those individuals going through the program will become familiar with what to expect out of it. And here you'll actually see there's about 45% on software defined, 25% on software defined, and 15% on infrastructure and automation. That's 40%, what's my maths? That's yes. About 40%. 40% of the lab exam is now programmability and automation. And this is where a lot of people stumble. So if you're doing this process on your own in an unstructured format, what typically happens is these are the areas that you really structure. Now, we've got mentors, we've got guidance facilitators throughout the program to support you. We've got somebody who watches you and helps you maintain up with the pace that's required to get through within that 12-month period. It is difficult. It's supposed to be difficult. A CCIE is by far one of the most respected certifications in the IT industry today, by far, okay? And we've seen that. If you've got that as on your CV, it comes very highly regarded, okay? And I'm going to hand back this section back to you.
Thank you. Okay. So you have the intro, you have the general idea of what we're trying to achieve, help you pass your CCIE, right? And now I'm going to give you the timeline. I'm going to tell you how this program works. And this is going to be totally different to whatever you've done on learning and certifications from Cisco. Because learning and certifications are usually 3-day training, 5-day training, maybe it's a month program. This is 1 year. This is 1 year that you will live and breathe with us, that we will help you get to the knowledge you need to pass your CCIE. So first of all, there are prerequisites. There are 2 things that you need to do at the beginning. One, we're not going to take just anybody, because not everybody is ready. You know, to become an expert, you need to have a certain level of knowledge, and you also have to have a certain level of experience on the job, right? So first of all, you have to have your prerequisite, your core certificate done, right? Your core exam, not certificate, done. If you have that done, which is a prerequisite to do the CCIE lab exam, then we'll do a pre-assessment of your knowledge. There are 2 reasons here. One is to know if you're ready for the program. The other one is to help us, the mentor, the coordinator, everybody else, to know how much you know and help you in the areas where you are weaker, right? So it's a baseline for us. It's a knowledge baseline. After that, one too far. You go into the program, which takes, as I said before, an entire year. There are 3 phases to this program. Phase 1 is the longest, because you're going to be doing a lot of specific trainings on different topics to get you to have let's call it a critical mass of information in your brain and knowledge in your brain to take you to the CCIE bootcamp. That will be phase 2. So in phase 1, you're going to have basically 4 components in every one of the tracks, because there are several different tracks here, like there are several CCIEs. Cisco U is the first component. This is self-paced, because we do not expect your company to give you a year off. You're not going to be studying all the time. You're going to do this in your own time. Some people will get time from their managers during the day. Some people do it during the weekend. Some people do it during the week. It will be up to you how you manage your time during a particular week. And here, you do self-learning. But you're not on your own. All the time that you're doing this self-learning, you will have a mentor. That's item number 2 here. The mentor will be with you every step of the way, and they will give you a certain amount of hours every month. So it basically is 2 hours a week that you and your cohort, this is the team that is studying together, right? Because as I said, you're not on your own. You will be studying with other people that are preparing for the same thing. You and your cohort will have access to this mentor a certain amount of hours every week, 2 hours every week. Towards the end is more. Right? So second time is the mentor. The mentor is obviously CCIE certified. Third item that you have here is reporting. You will get reports every week on your progress. You will know where you're failing. If you get behind, we will tell you. And we will work with you to catch up. If you get behind 2-3 weeks, it's going to be very difficult for you to get to that, to the other steps on time. So we're going to be with you every step of the way to make sure that you are keeping track of every part of the knowledge that you need to acquire. Item number 4 is you get access to labs. You get access to CML, and we even give you some architectures so you don't have to just create everything on your own. So you get access to Cisco Modeling Labs. It's part of the program. So you don't even have to go. Some people, I don't know if you ever had to do that, if any of you have done your CCIE or studied, go and buy some equipment on eBay just to build a lab at home, right? We give you that as well. Now, once you have gone through that, which has been a few long months, you get to your CCIE bootcamp. This is a bootcamp that will take you 2 weeks. This is the time where your manager needs to give you that time off. It will have to be 2 weeks full-time attending this bootcamp. We will get you ready to go into the next phase. Now, if you require more time, we have helped many different candidates during the program. So Brad and his team has helped a lot of candidates. There are companies that will give you extra PTO days, so you can take more vacation to cope with the load. There are many solutions that we work with. There's a very human element to this program because we are with you 1 year. So there are many solutions that we have found for these kind of problems. Now that you've done your bootcamp, the next step is what Brad mentioned before, the mock exam. It's a simulation of the CCIE lab, which we've developed, again, with the help of learning and certifications from Cisco. So this hasn't been created on our own. And it is an architecture like what you get in the CCIE lab, which will be running in a data center, so you can go and sit there for 8 hours and you actually get qualified. So there's a method there to tell you how well you did and how many points you got in each area. If you do well at that step, after this, you go and you take your CCIE lab exam. Included in the price and the cost and the investment that you made is also the CCIE lab voucher. And here you have 2 tries that you can try. The first one, you get a voucher, you just go, right? The second one is an insurance policy, we call it. You pay for it, and if you pass, we'll give you your money back. Anybody has any idea why we did it like that? Why we didn't give you just 2 vouchers? What happens if I give you 2 vouchers to pass the CCIE? You probably just go the first time to try it. Just to try it, and the second time you pass. So we wanted you to take it seriously on the first try. So that's why we did it this way.
Correct.
Okay.
Can I just go back there as
yes,
well,
of course.
please? So just with regards to the boot camp as well that you take away, what we've actually done is we've contracted in, if some of you know a gentleman by the name of Narbek Cochrane, so very well renowned and respected in the industry and taking individuals across the line at the last stage of their effort to become a CCIE. He's part of this. Okay, so he's actually embedded in this. His organization is embedded in this. And they are the ones that whiteboard it and take you through and build the topologies and the simulations around how to get through, specifically on the SD type stuff where the guys are struggling. He is actually a big part of it. And the engineers that have been through, when they get to Narbek, they kind of realize just how much they still don't know. And he kind of gets him to a point of readiness. Okay, so well respected. Look him up if you don't know him. very well respected in the industry as well. Thank you.
Thank you, Brad. Yeah. Now, the tracks. Enterprise infrastructure. That was the first track that was developed, and obviously, there's a track on 525 for enterprise infrastructure. Security is also there already. Data center as well. Service provider. Those are the 4 that we have at the moment. There's more coming. So we are aiming to have a track of 525 for every expert certification from Cisco. How does this look? This is a little bit of a more detailed table, but you have your pre-assessment, your prerequisite to enter the program, the month in the program, 12 months in total, the mentor hours you get for every month in the program. Also, the reporting is across the entire program, the 12 months. The CCIE track, specifically what trainings are included. So this is the list of trainings that you get in Cisco U. You will also get, as part of this program, you will get 2 vouchers to pass electives of CCNP. If you only have your Encore, but you don't have your CCNP certification, you can use one of these vouchers, or both of them, to pass an elective with Cisco. So you can then get your CCNP certification before you get your CCIE. This is an estimated number of hours of how much time you're going to have to study every month. On average, people spend about 1,000 hours of their time studying, preparing for the CCIE exam. Some people spend double that time, some people slightly less. So this is just an estimate. It's up to you and how you study and how you prepare, how much more time or less time you need. Now, that's enterprise infrastructure, and this is the reason we are here. Actually, around the corner there's a booth from Neil Learning, and the reason why we're sponsoring this year is because we are launching 525 in Europe. So it's coming from Africa into Europe now, and enterprise infrastructure will be the first one to be running in Europe as well. We have 3 more. This is security, service provider, and data center. You will get the slides afterwards, so if you need to peruse this because you're pursuing another CCIE, you get that so you can see what will be included in those programs. And these 3 programs will be launched in Europe in about springtime, right? So these are going to be running also very soon. So do get in touch if you are interested on attending any of these programs. There you go. Back to you, Brad.
Right. Okay, I'm going to go back one slide, and just very importantly is this particular row here. I think if anything's not managed and controlled, there's no way of telling just how you're progressing as well. So what we did was we worked, as I said, quite closely with the learning and certifications guys, and we built out a very comprehensive reporting. In fact, we utilized some of Cisco's input into this report on how we actually extract the information. And what you can see here is it's very detailed and quite granular, and it can actually get a lot more granular than this as well. But what Elizabeth was talking about earlier is that we can actually draw a report. This is the kind of content that we'll extract from that report to provide to a line manager. So if you're a line manager in here, what is the return on my investment on the individual going through this program? One is certainly going to be the knowledge that they're going to acquire through the program, and 2 is obviously I'm going to be able to see how they're progressing and are they going to actually succeed and come out the other side successful. And this kind of gives that feedback both to the mentor, who is very critical to this, because once the mentor identifies where they're falling down, they can actually assist in bringing them back up to that particular point that they need to be. And also the line of business manager sees the progress of the individual. So we can see the kind of how far they've progressed on the learning path, how many courses are outstanding on the individual, and we can pull this report and readily provide it to anybody that's actually going through the actual program itself. And that's a little bit more detail on how granular it can go and how we can select on an individual, or if an organization had a closed enrollment for one of the cohorts, they'd be able to see a full report and a diagnosis on all of the delegates on that program as well. So very important component is how does the organization measure the output of the individual and how committed are they? If there isn't a report, we wouldn't even know where they are. So what we've also got is a project administrator in the actual program supporting the mentor and sits in weekly with the mentor as well, just to they communicate with the individual. If life happens, okay, something happens to an individual, the program administrator will pick that up and report that back to the mentor, and we will also get provided that information to share with the line or the organization as well, which is very important. Okay, so some of the key points that we've spoken about, and just in summary on what we've covered today, is we are able to actually bring the labs to a specific country. I'll give you an example. We talk to the learning and certification team and we ask if it's possible to take the labs to a country, because in South Africa, what we typically had to do was fly to Brussels or to Dubai or to the US to go and do it. That takes out a lot of time from the CCIE. It's very stressful. There's jet lag. All of those components come into play. So now we can actually take the labs to a specific country that is under request. And we put a motivation through, and typically it's been signed off as a positive. I'll give you the latest one was Nigeria, where we've been able to actually allocate labs to Nigeria to run the labs as well. Okay, so that's very important because we can bring the labs to that country. All right, mentors, we've spoken in depth about the mentor, very critical. The pre-assessment exam goes to the mentor. The mentor then identifies the weakness of that individual that's going through the program and can specifically apply attention to the individual while going through that particular program itself. Covering the boot camp we've spoken about and how we've got Micronics involved in it. The supported simulations, we've spoken about how that lab, before you go in to do your final lab, will give you a true test because it's going to be graded and we'll understand exactly where you are before you actually go and conduct your lab exam, your final lab exam. You've got access to the practice labs. The mobile exams we've spoken about, we've got a rewrite built in there, but as we've said, it is an insurance policy, so we're trying to drive a particular behavior for the individuals. There's mentorship, membership into what's called the CCIE Club. This is in Africa. I don't know if it's practiced around the world, but certainly in Africa, we want to celebrate CCIEs. We want to really get them together as a community and really have an energy around, you know, these, because CCIEs are typically mentors to the CCNPs and the CCNAs within an organization, and they want to aspire to actually become a CCIE at some stage as well. It also counts to your Cisco continued education credits. Okay, so that's also very big for people who want to recertify and maintain certification as well. And then we've spoken about the 2 electives that are built into the actual program as well. So that's, Elizabeth, that's really it. I think we've done well. We've stayed within our time.
If you want to find out more about the program, you can go to either of these 2 websites. For Africa, it will be the link at the top, or you can just grab Brad and talk to him. For Europe, it will be the one at the bottom, or you can talk to me at any time. If you have any more questions or you want to talk to us directly, we are around the corner at the booth from Nil Learning. We have these little remote control cars there. You will see us. And any questions from you guys? Any comments or questions from anybody in the audience? I would love to hear anything from you. The cost for the program. So the cost is 145 CLCs or $15,000. So that is the cost. Do you think, let me ask you then a question. Do you think that's expensive with everything you have included? It depends, obviously it depends. Taking into consideration all the licenses, the access, the vouchers that you get, it's actually a pretty good price, let me tell you guys. It's a year of training that you will be getting worth in that price. Any other questions?
Yes.
Sorry? Should we be on site all the time? Oh, that's a good question. He's asking whether they need to be on site to attend this training. No, the majority of is done remotely. If we do get a team of enough capacity that will be local, then we may consider doing some of the mentoring and the stuff locally. But most of the time, we get people from different countries joining the same team. So the mentoring is done remotely. The boot camp can be done remotely. So it depends on whether we have enough to make it local, but mostly it is virtual. Yeah?
Just in terms of the cost as well, some of you may know Dave Mallory and Chris Ferreira over there as well. He's been very much part of building this with us. And Dave's just reminded me, just from the cost perspective, all the lab costs are actually included into the program itself as well. Okay, so that's quite a bit that's been included into the actual program. So there's no hidden costs over and above what we've...
The exam as well, and the rewrite
included.
As well. Yeah.
The vouchers, the lab costs, all of those kinds of things. It's all inclusive in the actual program.
So if you like what you heard, give a nod today, because without him, we wouldn't be here.
His whole certification team. But thank you. Really
thank you very
appreciate
much,
your time, everyone. We've got 59 seconds, so if there's any questions,
One more
field
question?
them or come and chat to us. If you want to break it down and drill it down, please come and chat to us. We'd really like to share the information with you. But thanks very much for your time today.